T-minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here. Endeavor, go at throttle up.
But at midnight, it was U.S. Secretary of State Colin Powell who was on hand to press the button that lowered that giant Waterford crystal ball, the traditional fireworks display, as you see, following in Times Square. Well, on this New Year's Day, Pope John Paul II is calling on all men of goodwill to renew their commitment to world peace. In his annual New Year's Day prayer service, the pontiff added prayers for those killed in the tsunami disaster. John Paul has made several calls in the past few days for international support for the tsunami victims. The tragedy in southern Asia has dampened New Year's celebrations around the globe. Anderson Cooper takes a look at that.
The sadness surrounds them, sorrow in nearly every face. In Phuket, Thailand, this isn't how anyone planned to bring in 2005. A massive candlelight vigil, mourning those lost, remembering those still missing. In Indonesia, most government agencies canceled fireworks displays and urged people instead to pray. Across India, New Year's celebrations were also canceled. As one official said, it doesn't feel right to host parties. There was a minute of silence before midnight in Sydney, Australia, where authorities said it was too late to cancel the New Year's Eve gathering in Sydney Harbour. TV coverage of the Sydney fireworks turned into a telethon for tsunami victims.
The giant disco ball there hanging from the Sydney Harbour Bridge, it doesn't get much better than that. Of course, tonight we are here raising money for a very important appeal, the Lord Mayor's appeal. Tonight we ask you to dig deep and give generously.
It may have sounded a little unusual, but they raised about $750,000. There was a pall over New Year's celebrations in Europe. In Paris, black cloth draped the Champs-Élysées. In Berlin, flags on government buildings greeted the new year at half-staff. At the Vatican, Pope John Paul II prayed for victims of what he called this huge tragedy. He also urged the world community to rush aid to the survivors. New Year's festivities in Sweden, in Norway, in Denmark, and Finland were canceled as well. Mindful of the images we've all been seeing, officials there called on people to ring in 2005 with dignity.
Neujahr, 6:15, hier ist RTL aktuell. Bundeswehrsoldaten auf dem Weg ins Katastrophengebiet. Die Truppen sollen in Indonesien ein Lazarett errichten. Das Sanitätsschiff Berlin nimmt Kurs auf Sri Lanka. In vielen Gebieten warten die Menschen verzweifelt auf Nahrung und Medikamente. In einem ersten Notlager ist die befürchtete Choleraseuche ausgebrochen. Knapp eine Woche nach dem Beben retten Helfer auf der Insel Sumatra einen Verschütteten. Auf der ganzen Welt feierten die Menschen Silvester unter dem Eindruck der Katastrophe. Guten Abend und herzlich willkommen zu RTL aktuell am 01.01.2005. Trotz der bedrückenden Nachrichten wünschen wir Ihnen zunächst ein gutes neues Jahr. Silvester haben viele Menschen, wie hier in Berlin, zwar gefeiert, aber angesichts der vielen Opfer in Südasien war die Stimmung gedämpfter als sonst. Bei vielen öffentlichen Feiern wurde für die Flutopfer gesammelt. In New York, London und Sydney legten die Menschen Schweigeminuten ein. Fassungslose Trauer herrschte zum Jahreswechsel in Schweden. Aus dem Land werden die meisten Touristen vermisst. Wir berichten später in der Sendung ausführlicher über die Silvesterfeiern. Jetzt zunächst zur Lage in den Katastrophengebieten in Asien. Knapp eine Woche nach dem Seebeben gibt es große Probleme, die Überlebenden zu versorgen. Hilfsgüter kommen zu vielen Opfern gar nicht durch. Und in Sri Lanka, das haben Ärzte vor wenigen Minuten bestätigt, ist die hochgefährliche Durchfallkrankheit Cholera ausgebrochen. Die Bundesregierung hat in der Nacht beschlossen, deutsche Soldaten nach Indonesien zu schicken, die dort ein Lazarett errichten sollen. Mario Turic berichtet.
Mehr als 120.000 Tote, er aber lebt. Ihsan Azmi lag 5 Tage lang unter Trümmern auf der indonesischen Insel Sumatra. 5 Tage ohne Essen und Trinken. Der 27-Jährige ist völlig entkräftet, aber nur leicht verletzt. Doch solche kleinen Wunder bleiben die Ausnahme. Es sind fast nur Leichen, die die Helfer bergen. Den Millionen Überlebenden fehlt es an vielem. Hilfsgüter kommen zwar in den Krisenregionen an, die Verteilung in entlegene Gebiete wird aber mehr und mehr zum Problem. Um uns verwesen die Leichen, sagt diese Indonesierin. Wir brauchen unbedingt sauberes Wasser und Nahrung. Inzwischen kreuzt der amerikanische Flugzeugträger Abraham Lincoln vor der Küste Sumatras. Seine Hubschrauber sollen helfen, Nahrung und Medikamente schnell den Millionen hilfsbedürftiger Menschen zu bringen. Auch die Bundesregierung plant, ihre Hilfe in Indonesien zu intensivieren.
Die Bundeswehr wird in Aceh ein Bundeswehrlazarett einrichten. Sie kennen diese flugverlegbaren Lazarette. Das Vorauskommando wird umgehend entsandt. Die Entscheidung ist gestern schon gefallen. Und das Lazarett wird dann in wahrscheinlich weniger als einer Woche einsatzfähig sein.
Hilfe, die dringend benötigt wird. In Banda Aceh leiden nach Angaben von Ärzten jetzt schon mehrere hundert Menschen an Symptomen der Cholera, eine Seuche, die durch mit Fäkalien verunreinigtes Wasser entsteht. Während diesen Menschen keine Wahl bleibt, werden mehr und mehr verletzte Urlauber in ihre Heimat ausgeflogen. Die Suche nach den Vermissten kommt dagegen nur schleppend voran. Wir vermissen noch viele Landsleute, sagt der schwedische Botschafter in Thailand. Zur Stunde sind es etwa 3500. Außer Schweden sind vor allem Deutsche betroffen, mit 34 identifizierten Toten bisher und mehr als 1000 Vermissten. Aus Italien starben 14 Menschen, von etwa 700 fehlt jede Spur. Norwegen beklagt derzeit 21 Tote und 462 Vermisste. Insgesamt verschwanden nach der Flut mehr als 7000 Urlauber spurlos. Möglicherweise wird ihr Schicksal nie geklärt werden.
Das gilt wohl auch für viele vermisste Deutsche. Staatssekretär Chariot, den wir eben schon gesehen haben, sagte, die Wahrscheinlichkeit, dass viele der über 1000 vermissten Deutschen nicht zurückkehrten, sei groß. Und er richtete einen Appell an die Verwandten.
Ich möchte ganz dringend davon abraten, hier selbst jetzt in die Region reisen zu wollen. Warum nicht? Es gibt da eine ganze Reihe von Gründen. Erstens, Sie können in der Region im Augenblick nichts bewirken. Wir haben Experten vor Ort, die das Menschenmögliche tun, um mit DNA-Analysen, und Sie wissen alle, wir sind im Augenblick im Wesentlichen auf die DNA-Analysen angewiesen, um mit DNA-Analysen hier vorzugehen.
Angesichts der schlimmen Lage rund um den Indischen Ozean fielen die Silvesterfeiern an vielen Orten gedämpfter aus als normalerweise. Wie die Menschen in Deutschland und anderen Ländern das neue Jahr begrüßt haben, Lothar Keller.
Die Flagge hing auf Halbmast am bunt angestrahlten Brandenburger Tor. Auch das zeigte, Deutschlands größte Silvesterparty in Berlin war nicht wie sonst. Es kamen weniger Besucher, 800.000 statt 1 Million, und viele ließen es ruhiger angehen.
Ich habe natürlich andere Veranstaltungen im Gedächtnis, die waren natürlich weit ausgelassen. Das ist völlig außer Frage.
Das Feuerwerk an der Siegessäule konnte sich trotzdem sehen lassen. Entschädigung dafür, dass privat hier nicht geböllert werden darf. Und gegen ein schlechtes Gewissen beim Feiern half der Griff zum Handy. Denn mit einer SMS konnte jeder 2,65 € an UNICEF spenden. Fast 350.000 € kamen zusammen.
Also ich finde die Idee wirklich schön. Wenn das Geld dort ankommt, wo es ankommen soll, ist es super, sage ich mal. Gute Idee.
Besonders farbenprächtig waren auch in diesem Jahr die Silvesterfeiern in London und in Paris. Doch auch auf den Champs-Élysées trugen die Bäume einen Trauerflor. In New York brachte US-Außenminister Powell um Mitternacht eine große Kugel an Times Square zum Leuchten. Ganz anders die Silvesternacht in Schweden. Sie glich eher einer Trauerfeier angesichts der 2500 Menschen, die nach der Asienflut noch vermisst werden. Nie zuvor ist uns der Schritt in ein neues Jahr so schwer gefallen, sagte Ministerpräsident Persson am Silvesterabend. Und so war der Jahreswechsel überall, auch hier an den Hamburger Landungsbrücken, etwas nachdenklicher als sonst.
Trotzdem sollte man sich freuen darüber, dass man hier in einer freien Republik wohnt. Und dass wir diese Freiheit und die Möglichkeiten haben und die große Liebe haben.
Und das ist dann doch ein Grund, sich ganz privat aufs neue Jahr zu freuen, trotz allem.
Gebet für Tsunami-Opfer. Auch die Neujahrsbotschaft des Papstes war geprägt von der Trauer um die Flutopfer in Asien. Seine Gedanken seien bei den Völkern, die von der tragischen Naturkatastrophe getroffen wurden, sagte Johannes Paul II. Vor tausenden Gläubigen auf dem Petersplatz in Rom. Ausdrücklich lobte er die große Spendenbereitschaft. Die menschliche Solidarität auf der ganzen Welt gebe Anlass zur Hoffnung auf bessere Tage im neuen Jahr. Jagd auf Rebellen. Die US-Armee hat im sogenannten Dreieck des Todes um Bagdad eine neue Offensive gestartet. Von dort werden nach wie vor Raketen abgefeuert. Auch geraten dort jeden Tag Soldaten und Zivilisten in den Hinterhalt. Mit solchen Anschlagsvideos versuchen die Rebellen zudem, das irakische Volk einzuschüchtern. In einer Internetbotschaft warnten sie, der Arm der Mujahedin werde alle erreichen, die an den Wahlen teilnehmen.
Deutschlands größte Silvesterparty, doch nur auf den ersten Blick Festtagsstimmung wie zu jedem Jahreswechsel in Berlin. Mit rund 700.000 Menschen waren deutlich weniger Besucher als erwartet auf die Partymeile am Brandenburger Tor gekommen. Die feierten ausgelassen und viele halfen dennoch den Flutopfern. 2,65 € pro Anruf. UNICEF und der regierende Bürgermeister hatten hier zu Spenden per SMS aufgerufen. Gemischte Neujahrsgefühle.
Man feiert, weil das ist irgendwie drin, aber man hat schon ein bisschen schlechtes Gewissen.
Ich bezweifle, dass die Hälfte überhaupt der Leute darüber nachdenkt.
Wir haben normalerweise vorgehabt, nächstes Jahr in Urlaub zu fahren, also einen größeren Urlaub, eigentlich auch in diese Region, die es halt gerade betrifft. Und das haben wir jetzt gecancelt und das Geld haben wir dementsprechend gespendet.
Furiose Knalleffekte währenddessen über der Themse in London. Gedämpfter als üblich die Feierlichkeiten in Paris. Dennoch Feuerwerk auf den Champs-Élysées. Anders im Norden. Stilles Silvester in Stockholm, Kerzen für die Toten, das offizielle Großfeuerwerk abgesagt. Über 3.500 Schweden werden noch in der Flutregion vermisst, mehr als aus jedem anderen europäischen Land. Nie sei der Schritt in ein neues Jahr schwerer gewesen, so der schwedische Ministerpräsident Persson. Silvester im Zeichen der Flutkatastrophe. Bei der UNICEF-Spendenaktion waren allein in Berlin fast 400.000 € zusammengekommen.
Jetzt im raschen Überblick weitere Nachrichten vom ersten Tag des Jahres.
Gebete für Flutopfer. Papst Johannes Paul II. Hat an Neujahr der Opfer in Südasien gedacht. Er lobte die große Solidarität auf der Welt. Außerdem rief er beim Neujahrsgottesdienst im Petersdom zu Frieden und Vergebung auf. Die katholische Kirche feiert am 1. Januar traditionell den Weltfriedenstag.
Eine riesige Welle mit Kurs Richtung Europa, eine durchaus reale Bedrohung. Die Gefahr lauert vor Norwegens Küste. Es ist aufsteigendes Methangas, das dort den Meeresgrund porös macht. Vor etwa 8000 Jahren kam dadurch bereits ein gewaltiger Hang ins Rutschen und löste eine Monsterwelle aus, die auch bei uns gewaltige Schäden anrichtete. Die Wissenschaftler glauben, dass der Meeresboden vor Norwegen irgendwann erneut abrutscht. Ihre Befürchtung, einige Flutwellen könnten von Island wie eine Billardkugel abprallen und dann bis in die deutsche Bucht schwappen.
Ja, wenn wir eine Tsunamiwelle in der Nordsee haben, dann wird es auch Überschwemmungen geben und es kann auch zu Schaden kommen. Und unter Umständen reichen auch die Deiche nicht, die dort vorhanden sind.
Eine andere tickende Zeitbombe ist der Vulkan Cumbre Vieja auf der Kanareninsel La Palma. An seiner Westflanke entstanden bei früheren Ausbrüchen riesige Risse. Beim nächsten Ausbruch könnte ein 25 mal 15 Kilometer großer Kraterrand ins Meer stürzen. Die Folgen wären bereits 3 Stunden später bei uns zu spüren. Am heftigsten aber träfe es den amerikanischen Kontinent. Nach 7 Stunden würden Floridas Traumstrände oder, wie in diesem Katastrophenfilm, New York von einer etwa 25 Meter hohen Welle erreicht, die noch kilometerweit ins Hinterland schwappt. Die Wissenschaftler sind sich sicher, dass dies einmal passieren wird. Nur wann, weiß keiner.
12.000 Armeeangehörige sind im Einsatz, um Nahrungsmittel und Medikamente in die zerstörten Gebiete zu bringen. Die internationale Gemeinschaft hat inzwischen über 1,5 Milliarden € an Spenden zusammengetragen. US-Medien rechnen damit, dass der Kongress nochmals $1 Milliarde Soforthilfe genehmigen wird.
Aber es geht nicht nur um Geld. Es geht darum, Hilfsgüter in die Region zu bringen. Und wenn wir die Hilfsgüter zu den Flughäfen gebracht haben, wie bringen wir all das zu den Menschen, die es brauchen? Dafür brauchen wir Lastwagen, Hubschrauber, Schiffe. Es geht nicht darum, nur viel Geld zu spenden und dann kann es keiner verteilen.
Paul machte zugleich, dass nicht die Vereinten Nationen, sondern die USA allein entscheiden, wo und wem sie helfen. Weil Wissenschaftler in Thailand lieber stundenlang diskutierten und ein Beamter in Indien die falsche Faxnummer wählte, sind wahrscheinlich so viele Menschen in den Fluten ums Leben gekommen. Denn inzwischen ist klar, 2 ganze Stunden bevor die todbringende Flutwelle an Land krachte, gab es zahlreiche ganz konkrete Hinweise auf sie. Doch die Experten behielten ihr Wissen für sich. Die Bevölkerung in den 12 betroffenen Ländern wurde nicht gewarnt. Doro Steitz berichtet.
Es ist gegen 18 Uhr Ortszeit, kurz vor 8 in Asien, als die Mitarbeiter des Geologischen Dienstes im amerikanischen Denver ein Erdbeben der Stärke 9,0 im Indischen Ozean registrieren. Sie veröffentlichen ihre Tsunami-Warnung im Internet, doch offenbar sehr gut versteckt. Auch die zuständige US-Behörde für Meeresforschung will nur 16 Minuten nach der ersten Information offiziell gewarnt haben. Alle, die an das internationale Warnsystem angeschlossen sind. Indien und Sri Lanka sind es nicht. Hätten diese Länder ein Warnsystem gehabt, viele der Menschen weiter nördlich hätte man retten können. Sie hätten 2 bis 4 Stunden vorher gewarnt werden können. 12.000 Kilometer entfernt, hier in Thailand, diskutieren die Meteorologen fast 2 Stunden, bevor die Welle Phuket erreicht, wie gefährlich sie wohl ist. Offenbar, um der Tourismusindustrie nicht zu schaden, bleiben Warnungen aus. Und in Indien habe die Luftwaffe 1 Stunde vor der Welle Bescheid gewusst. Die Warnung des örtlichen Meteorologischen Dienstes geht 2 Stunden später an den Minister für Wissenschaft und Technologie und dann auch noch an den Falschen. Der Mann war längst abgewählt. Pannen und Fehleinschätzungen, die Leben gekostet haben. Aber die Experten wissen auch, die schnelle Warnung ist das eine, die richtige Reaktion das andere.
Eine Warnung allein reicht wahrscheinlich nicht aus. Die Information muss zu den Leuten gebracht werden. Die Leute müssen eventuell evakuiert werden oder so. Also es gehört schon ein gut funktionierendes System dazu.
Geistesgegenwärtig reagiert hat hingegen ein südindischer Fischer. Er warnte über Lautsprecher die 7000 Bewohner seines Dorfes und drängte sie landeinwärts zu laufen. Dieser Mann hat die Zeichen der Natur richtig zu deuten gewusst und gehandelt.
Tsunami Warning Center, Honolulu, Hawaii, 26. Dezember, kurz nach 15 Uhr Ortszeit. Die Messgeräte melden ein Erdbeben der Stärke 8,9, das stärkste Beben seit 40 Jahren. Ein warnender Anruf kommt hier nie an. Die Küsten Indonesiens, Thailands, selbst Teile Afrikas werden von einer gigantischen Flutwelle überrollt. Der Tsunami löst eine Jahrhundertkatastrophe aus. Ganze Landstriche sind komplett verwüstet. Millionen Menschen verlieren ihr Zuhause. Zehntausende sterben in den Fluten.
Ja, das ist das Tragische an der ganzen Geschichte. Man hätte zumindest Minuten bis Stunden Zeit gehabt, eventuell die Bevölkerung zu warnen und damit die Schäden sicher hätte reduzieren können.
Die Ursache der Katastrophe, die Bewegung der Erdplatten. Dort, wo sie sich treffen, droht Gefahr. Im Meer vor Sumatra drückt die indisch-australische Platte auf die eurasische. Das führte zu einem gewaltigen Seebeben.
Auf einer Länge von etwa 1000 Kilometern hat sich dort der Meeresboden um Größenordnung bis 10 Meter wahrscheinlich gehoben oder gesenkt. Und das heißt, schlagartig muss die Meeresmasse, die Wassermasse, muss danach nachgehen. Und das führt dann zu der Erzeugung dieser Wellen, dieser Flutwellen, die man Tsunamis nennt, die sich dann letztendlich um den ganzen Erdball auf den Ozeanen ausbreiten und die zu diesen verheerenden Schäden geführt haben.
Über den gesamten Globus verteilt gibt es Erdbeben-Messstationen. Eine davon in Fürstenfeldbruck, Bayern. Das Beben war so stark, dass es hier im Geophysikalischen Observatorium sofort registriert wurde. Professor Heiner Igel ermittelte, dass sich selbst in Bayern die Erde während des Bebens um 5 Zentimeter hob. Jede Messstation ist in der Lage, das Epizentrum eines solchen Bebens innerhalb von wenigen Minuten zu orten.
Das Erdbeben war etwa 60, 70 Kilometer vor der Küste von Sumatra. Da bleibt natürlich dann nicht viel Zeit, also ein paar Minuten, bis die Welle dann in Sumatra ankommt, wohingegen auf der anderen Seite des Indischen Ozeans, also Sri Lanka und vor allem natürlich die Ostküste von Afrika, die 4.500 Kilometer entfernt ist, da hätten sie eine Stunde oder mehrere Stunden Zeit gehabt.
Die Menschen in den betroffenen Gebieten jedoch wurden völlig überrascht von der Welle. Es gab keinerlei Vorwarnung, obwohl jede Erdbebenstation den Tsunami hat voraussagen können. Zigtausende Menschenleben hätten gerettet werden können. Auf Hawaii existiert seit 1948 ein Warnsystem. Die Wissenschaftler bestimmen innerhalb von etwa 4 Minuten Herd und Stärke des Bebens und lösen Alarm aus. Hawaii liegt ungeschützt mitten im Pazifik. Hierher werden die Killerwellen besonders oft gelenkt. Die Stadt Hilo wurde 1946 von einem Tsunami zerstört. Todesopfer über 100. Um Tsunamis frühzeitig aufzuspüren, müssen Meldesysteme in der Tiefsee installiert werden. Das Pacific Marine Environmental Laboratory hat ein spezielles Druckmesssystem entwickelt.
Dies hier ist das Kernstück der Anlage. Da drin gibt es eine Druckkammer. Sie misst den Wasserdruck in dieser kleinen Röhre hier. So kann die kleinste Veränderung in der Höhe des Wasserspiegels erkannt werden, also der Druck. Die Daten werden zu diesem Mikroprozessor gesendet. Dieser stellt fest, ob es ein Tsunami war oder nicht. Dann wird die Information an das Mikrofon geliefert und schließlich nach oben zur Boje.
Das Messsystem befindet sich auf dem Meeresboden. Informationen über einen veränderten Wasserdruck sendet es per Schall zu einem Unterwassermikrofon. Von dort gelangen die Daten auf eine Boje an der Wasseroberfläche und dann durch eine Satellitenverbindung an einen Empfänger an der Küste. Sofort kann vor den heranrasenden Wellen gewarnt werden. An den Stränden heulen Sirenen auf. Straßenschilder weisen den schnellsten Weg in Sicherheit. Und die Menschen lernen, mit der Gefahr zu leben.
Okay, das Signal für die Evakuierung. Alle in eine Reihe.
Einmal im Monat üben die Kinder an der Schule, wie man sich vor einem Tsunami in Sicherheit bringt. Sie müssen dazu einige Kilometer ins Innere der Insel laufen.
Okay, stopp. Gut gemacht. Wir haben es in 20 Minuten geschafft. Wir warten hier. Bleib bei mir.
Ebenfalls ständig durch Tsunamis bedroht Japan. Hier verfügen viele Städte neben einem Frühwarnsystem über hohe Schutzmauern. Regelmäßig übt die Feuerwehr den Katastropheneinsatz. Ihr Ziel, in nur wenigen Minuten die großen Tore zu schließen. Durch Frühwarnsysteme und Staumauern wappnen sich die Industrienationen gegen Tsunamis. In Thailand soll jetzt ebenfalls ein Schutzsystem installiert werden. Wollte man den ganzen südostasiatischen Raum damit ausstatten, würde das mehrere Milliarden Euro kosten. Für viele der armen Länder unbezahlbar. Tsunamis entstehen hauptsächlich durch Erdbeben unter Wasser. Daher ist es das Ziel der Forscher, die Beben vorhersagen zu können und dann vor den Killerwellen zu warnen. Dabei sollen in Zukunft Satelliten helfen. Sie messen Temperaturschwankungen und Veränderungen im Magnetfeld. Diese Phänomene können auf Beben hinweisen. Auf der Erde werten die Wissenschaftler die Daten aus und warnen im Notfall. Momentan wird diese Methode noch erprobt.
Was uns fehlt, ist eigentlich wirklich, welche Kräfte wirken im tiefen Erdinnern, nämlich genau da, wo das Erdbeben entsteht. Die entstehen ja nicht an der Erdoberfläche, sondern zum Teil in 10 Kilometer Tiefe oder wie hier jetzt geschehen, in wesentlich größeren Tiefen. Eigentlich müssten wir die Erde aufreißen und reinschauen können, aber das können wir einfach nicht.
Gelingt es den Forschern mehr über das Geschehen im Erdinneren zu erfahren, könnte eine solche apokalyptische Katastrophe wie in der letzten Woche in Zukunft vielleicht verhindert werden.
Sprung nach Bonn in die Operationszentrale des Technischen Hilfswerks. Das THW ist wie andere Organisationen dringend auf Satellitendaten angewiesen. Für die Einsatzteams draußen im Katastrophengebiet liefern sie zum Beispiel Anhaltspunkte dafür, ob Straßen noch befahrbar, Regionen überhaupt noch erreichbar sind.
Also der Vorteil dieser Technik ist, dass wir hier in der Heimat schon sehen können, wo gegebenenfalls große überschwemmte Gebiete sind und unseren Leuten vor Ort Wege versperrt sind.
Aus 600 Kilometer Höhe liefern vor allem die beiden Satelliten QuickBird und Iconos die fast metergenauen Aufnahmen. Zum Teil veröffentlicht auch auf der Internetseite des Deutschen Zentrums für Luft- und Raumfahrt. Ergänzt werden müssen die Erkenntnisse aus dem All, aber stets mit Erkundungen vor Ort. Am besten Überflüge, um den Hilfsorganisationen möglichst detaillierte Planungsdaten bereitzustellen.
Die Antonov landet in Köln-Wahn. In den riesigen Bauch des Transportflugzeuges passen etwa 90 Tonnen Fracht. Einen solchen Flieger besitzt die Bundeswehr nicht. Er musste für diesen Einsatz extra von Russland gechartert werden. Die Fracht ist äußerst kostbar. Neben 3 Lkw ein mobiles Lazarett der Bundeswehr. Insgesamt wiegt das Hospital rund 300 Tonnen. Die ersten Module werden eingeladen. Die Möglichkeiten des Lazaretts sind enorm.
Wir haben im Lazarett selbst einerseits einen Operationssaal mit entsprechender Ausstattung. Wir haben eine kleine Intensivstation, wir haben 20 Pflegebetten, wir können Röntgen- und Ultraschalldiagnostik machen, wir haben ein kleines Labor, wir haben eine Apotheke.
Indonesien ist von dem Tsunami am schlimmsten betroffen. Hier wird das mobile Lazarett der Bundeswehr am nötigsten gebraucht.
Der Beitrag, den die Bundeswehr und insbesondere der Sanitätsdienst jetzt dort unten leistet, ist absolut dringend notwendig und wird in der Zusammenarbeit mit den anderen Nationen, mit den anderen militärischen Bestellern, aber auch mit den zivilen Organisationen großen Nutzen haben.
Die Sanitätseinheit der Bundeswehr soll den Menschen möglichst schnell helfen. Am Abend ist die Antonov mit dem ersten Teil des Lazaretts in die Krisenregion geflogen.
Saw 2004 ending with nature at its very worst. We saw 2005 starting with humanity at its very best.
The devastation exceeds anything that I had thought. Pictures cannot capture what the reality is.
Das Wetter in Deutschland hat heute verrückt gespielt. In München konnte man glauben, der Frühling sei schon da, und in Hamburg wurde sogar die wärmste Januarnacht seit 100 Jahren gemessen. Doch schon ein paar Stunden später tobte über Norddeutschland ein heftiger Orkan. Auf Sylt erreichten die Böen bis zu 180 Stundenkilometer. Und sie richteten auch Schäden an. Im benachbarten Dänemark starben sogar 2 Menschen, als ein Dach auf sie herabfiel. Sabine Tünker fasst zusammen.
Gegen die Orkanböen, die mit Tempo 160 auf dem Brocken im Harz wüteten, hatten die Spaziergänger auf dem vereisten Boden keine Chance. Nur mit vereinten Kräften kamen sie wieder auf die Beine und brachten sich vor dem Sturm in Sicherheit. Meterhoch peitschte Sturmtief Erich die Wellen an die Nordseeküste. Der Fährbetrieb funktionierte hier und an der Ostsee vielerorts nur noch eingeschränkt. Doch wie am Strand von Daggebühl waren viele Schaulustige sogar extra wegen der extrem steifen Brise gekommen.
Ab und zu ist ja doch mal so ein Sturm, ne? Aber heute ist richtig heftig.
Wegen dem faszinierenden Sturm, weil es jedes Mal ein Naturerlebnis ist.
Das heute, das ist ja Wahnsinn. Wahnsinn, muss man mal gesehen haben.
Doch der Sturm, der am frühen Nachmittag über Norddeutschland und den Mittelgebirgen seine volle Kraft entfaltete, richtete auch Schäden an. Bäume knickten um und tonnenschwere Lkw kippten um, wie hier bei Flensburg. Auf der B6 bei Nienburg drückte eine Windböe einen BMW in den Gegenverkehr, wo er in ein entgegenkommendes Auto krachte. Der Fahrer wurde schwer verletzt. Kaum zu glauben, dass diese Bilder auch heute entstanden sind. Strahlend sonnige und T-Shirt-taugliche 17 Grad in München. Die Menschen im Süden erlebten ihre ersten Frühlingsgefühle.
Ja, da kribbelt's im Bauch. Wir haben die Sonne gepachtet hier an dem Platz.
Für Januar ist es natürlich nicht normal, aber es ist natürlich geil, wenn es so ein schönes Wetter ist im Januar.
Sturm und Sonne und viel zu mild. Das Wetter in Deutschland spielt verrückt. Doch zumindest mit Sonne im Süden ist ab morgen erst einmal Schluss.
Orte wurden überschwemmt, Fähren mussten im Hafen bleiben und am Abend wurde in Schleswig-Holstein der Zugverkehr eingestellt. Auf der B5 bei Husum zeigte der Sturm alle Kraft, die in ihm steckt. Wie ein Spielzeugauto richtete er diesen Kleinlaster wieder auf, den er vorher umgeweht hatte. Mit Überschwemmungen hat der Norden Englands zu kämpfen. In der Stadt Carlisle mussten die Menschen mit Booten oder Hubschraubern in Sicherheit gebracht werden.
Guten Abend. Extreme Wettergegensätze heute bei uns. Strahlender Sonnenschein am Alpenrand, im Norden dagegen mehr Wolken und vor allen Dingen Wind. Schwere Sturm- und Orkanböen heute. Es hat auch schon entsprechende Schäden gegeben im Norden, alleine auf Sylt, bis fast 150 Kilometer in der Stunde. Und es geht auch mild und windig weiter. Die Tiefs vom Atlantik, die ziehen so schnell Richtung Mitteleuropa, dass die Kaltluft kaum Chancen hat zu verweilen. Denn auf Satellitenbildern kann man das Ausmaß der Verwüstungen durch den Tsunami sehr gut erkennen. Das sind Bilder von der Insel Sumatra aus dem Norden der Provinz Aceh und dort von der Westküste der Stadt Loknar. Zum Vergleich oder zur Orientierung erstmal ein Bild noch vor dem Tsunami und jetzt ein Bild nach dem Tsunami. Da sieht man also schon auf den ersten Blick, dass sich dort stark etwas verändert hat. Und wenn wir noch weiter ranzoomen, dann sieht man, dass die gesamte Vegetation weggeschwemmt wurde. Auch alle Häuser, auch die Agrarflächen standen noch Tage nach der Flutwelle unter Wasser. Und Wissenschaftler haben berechnet, dass die Welle etwa 15 Meter hoch war. Und diese Bilder sind eben sehr wichtig, weil man dort erstmal das Ausmaß der Zerstörungen überhaupt erfassen kann. Denn die Landschaft hat sich ja zum Teil auch stark verändert. Das war's vom Wetter heute. Ich wünsche Ihnen noch einen angenehmen Abend.
Hier ist Nordrhein-Westfalens ein Bild von ganz Deutschland und Sie sehen, wie die Front uns überquert. Und mit der Front sanken vorübergehend auch bei uns die Temperaturen, zum Beispiel Medebach-Schlossberg fast 800 Meter hoch, dann mal nur 4,5, sonst war es mild, zum Beispiel Emstetten 11,8 Grad. Und vor dieser Front, außerhalb von Nordrhein-Westfalen, in Sachsen, in Pirna fast 17 Grad an einem 8. Januar oder in Mühlacker in Baden-Württemberg fast 16 Grad, 15,6.
Ebenso schockierend der Blick auf Sumatra aus dem Weltraum, vor und nach dem Beben. Die Region Banda Aceh zu 2/3 zerstört, die Küstenlinie verschoben, Hafenanlagen und Brücken zertrümmert.
Das erste Exemplar des verbesserten Treibstofftanks für die Raumfähre Discovery ist in Cape Canaveral eingetroffen. Für die NASA die wichtigste Komponente für den im Mai geplanten ersten Shuttle-Start seit der Columbia-Katastrophe vor 2 Jahren. Damals hatte sich ein Stück des Tanks gelöst und die Isolationsschicht beschädigt. Beim Eintauchen in die Atmosphäre brach die Columbia mit 7 Astronauten an Bord auseinander. Der neue Tank soll jetzt sicher sein.
Temperaturen bei uns bis zu 15 Grad. Dann der Orkan Erwin. Mindestens 15 Menschen sterben, 2 davon in Deutschland. England trifft es besonders hart. Zum Orkan kommt noch eine der schwersten Überschwemmungen dazu, die das Land je erlebt hat. Sandra Schiffauer.
Mit bis zu 180 Kilometer pro Stunde fegte Erwin über den Norden Europas hinweg. Wie hier in Dagebüll in Schleswig-Holstein verwandelte die Sturmflut Küstenstraßen in Flüsse. Durch die Wucht des Orkans wurden selbst tonnenschwere Lkw umgeweht. Oberleitungen wurden zerstört, im hohen Norden fuhr kein Zug mehr. Auf dem Bramsee bei Kiel ertranken höchstwahrscheinlich 2 Schüler. Sie waren mit ihrem Kajak unterwegs.
Zeugen haben gesehen, dass die beiden versucht haben, das rettende Ufer zu erreichen. Und er hat sie dann aus den Augen verloren, als es untergegangen.
Chaos und Tote auch in Skandinavien. In Schweden und Dänemark riss Erwin mindestens 10 Menschen in den Tod. In Großbritannien traf der Orkan besonders schlimm den Nordwesten, wie hier die Stadt Carlisle. 3 Menschen starben. Helikopter und Boote bringen die Bewohner aus ihren überfluteten Häusern. Die Überschwemmungen hier sind die schlimmsten in England seit 40 Jahren. Und noch immer ist die Stadt komplett von der Außenwelt abgeschnitten. Das Wasser hat alles mitgenommen. Fernseher, Waschmaschine, Trockner. Ich wohne 23 Jahre hier. Sowas habe ich noch nie erlebt. Insgesamt 500.000 Menschen waren in Nordeuropa für Stunden ohne Strom. Die Bilanz: 15 Tote und mehrere Verletzte. Selbst in Berlin riss der Sturm noch Bäume aus. Diese S-Bahn krachte im Norden der Hauptstadt in einen Baum, der auf den Schienen lag. Verletzt wurde hier zum Glück niemand. Mittlerweile ist der Orkan weitergezogen und hat auch in Estland und in Russland gewütet.
18:45 Uhr, hier ist RTL aktuell. Stille Trauer. In Berlin gedenken Angehörige und Politiker aus allen Parteien der Opfer der Flutkatastrophe in Südasien. Dokumente Schreckens. Zum ersten Mal zeigen Amateuraufnahmen, mit welch unglaublicher Gewalt der Tsunami die am schlimmsten getroffene Stadt Banda Aceh überrollt hat.
Autos fahren nur wenige Meter vor der anrollenden Front. Panik bricht aus. Die Menschen begreifen, dass etwas nie Dagewesenes über sie hereinbricht. Die Flutwelle wird schneller, höher, lauter. Milliarden Kubikmeter brauner, schlammiger Brühe bahnen sich ihren Weg durch die Hauptstraße von Banda Aceh. Mittendrin ein ausgewachsener Baum. Der Tsunami hat tonnenweise Unrat aufgesogen, hunderte Autos mitgerissen. Wie ein wirres, aber dichtes Dach schwimmen Millionen von Brettern und Wellblechen bereits zerstörter Häuser auf dem tödlichen Fluss. Die Flutwelle schießt mit unglaublicher Kraft und Geschwindigkeit zwischen den Häusern hindurch. Wo sie auf Widerstand stößt, türmt sie sich auf, wirbelt ihr Treibgut in die Luft und rast dann umso schneller voran. Nur Minuten später haben sich die Wassermassen über die ganze Stadt ausgebreitet. Die Überlebenden sind wie gelähmt. Was die Flut hinterlassen hat, zeigen diese Luftaufnahmen. Banda Aceh im Januar 2005.
Wildes Klima bekannt, doch seit einigen Tagen peitscht eine Sturmfront über den US-Bundesstaat hinweg. Die Folge: schwere Regenfälle und Überschwemmungen. Mindestens 12 Menschen sind schon ums Leben gekommen.
Der peitschende Sturm vom Pazifik soll noch weitere 2 Tage das südliche Kalifornien in Regenfluten versinken lassen. Die Rettungsdienste müssen kleine Ortschaften evakuieren, die vom Wasser und Schlamm eingeschlossen sind. Und haben es oft mit Menschen zu tun, die mitgerissen wurden. Nicht immer gelingt die Rettung. Bisher sind mindestens 12 Tote zu beklagen. Dies ist eine Region, in der es, wie es im Schlager heißt, niemals regnet. Entsprechend schlecht sind die Bewohner, ihre Häuser und Straßen, die ganze Infrastruktur auf diese Sintflut eingerichtet. Die Wassermassen haben in den Bergen die Erde in Schlamm verwandelt. Und in dem Dorf La Conchita hat ein Erdrutsch Häuser und Menschen verschüttet. Mindestens 3 Bewohner kamen ums Leben. Die Bergungsarbeiten dauern an. Vorsorglich werden weitere Ortschaften geräumt.
Torrential rain and flooding. There's been storm after storm after storm. It means that emergency workers have been working overtime. Some of the pictures we've got in this week, some of the stories have been extraordinary. I've got so much material to show you over the next couple of hours. But we start with emergency workers saving a baby, not once, but twice. Soledad O'Brien has the story.
Daring and dramatic moments in Southern California. A 2-month-old baby rescued from raging floodwaters, not once, but twice. It happened in San Dimas. All seemed to be going well in the first rescue attempt. But watch. The inflatable raft carrying the rescuer, the mother, and her baby suddenly overturns, throwing all 3 into the water. Luckily, another rescuer rushed in and was able to reach them. He grabbed the baby, fighting through knee-deep water to get back to dry land.
Her and the baby were getting taken under, and I was trying to yell at her as she was moving downstream, hold the baby up, and every time I would say that, she'd actually listen, and she would try to get the baby up, but it was quite hard for her.
Officials say the infant's body temperature dropped to 90 degrees. He was quickly put into warm clothing and taken to a hospital where he's expected to make a full recovery. Soledad O'Brien, CNN, New York.
Mother and baby are now doing fine. The weather is still rough through that southern part of California. This is how much rain we've had in the last 24 hours. You may be thinking, well, that's not much. Let me wait and start the animation. You'll see, well, you see those most vivid colors piling in here. This is just 24 hours. This is just one of the storms that we've had moving through this Southern California area, heading up there into the northern Rockies as well, bringing with it incredible amounts of snow. The Lake Tahoe, Reno area, for instance, has seen the highest amount of snow in 90 years. Let's head across through towards the rest of the weather for the west. More rain just moving through. The problem that we're going to have with this wet weather, that rain as it heads up into the mountains turning into snow, so the next 24 hours until perhaps the end of your Tuesday, still seeing some really rough weather. Then there's a little bit of a break. I'll tell you what happens next in a moment. But we have very frigid air here and then really warm air here through the southern section of the US, up through into the plains as well. That's going to be a problem when you have that cold air meeting the warm air. In the next couple of days, we're going to have incredible heavy weather, thunderstorms and showers and more to come. Up through the northeast, also seeing some rain pushing through, some of it sleety, icy stuff there as well. Looking quite nice through the southeast, pushing down towards Florida. But behind that, here comes the rough weather. And along this boundary, this is where we're going to see some very, very serious weather indeed.
Großraum Los Angeles fiel seit Anfang des Jahres mehr Regen als sonst das ganze Jahr über. Steilhänge weichten deshalb auf und rutschten ab. In dramatischen Rettungsaktionen versuchten Helfer, die Menschen in Sicherheit zu bringen. Aus den USA dazu Volker Albers.
Für diesen Hang waren die tagelangen Regenfälle zu viel. Ohne jede Vorwarnung donnern immense Massen von Schlamm und Geröll auf den kleinen Ort La Conchita nordwestlich von Los Angeles nieder und begraben Häuser, Autos und Menschen unter sich. Wie unter Schock humpelt dieser Verletzte in Sicherheit. Fassungslos beobachten andere, was mit ihrem Heimatort geschieht. Rettungskräfte sind schnell vor Ort und suchen nach Opfern, bergen immer wieder Verschüttete und Verletzte. Mindestens 3 Menschen kamen bei dem Erdrutsch ums Leben, etwa 20 werden zurzeit noch vermisst. Ich kann es nicht glauben, sagt diese Frau. Ich sah gerade einen Freund sterben, das ist unfassbar. Alle Flüsse in der Region führen Hochwasser, mit ungeheurer Gewalt schießen die Fluten zu Tal und werden so schnell zu tödlichen Fallen. Hier bergen Rettungskräfte einen Mann, der in seinem Auto eingeschlossen war. Und diese Feuerwehrleute bringen ein Baby in Sicherheit, welches aus einem Boot fiel. Dieser Mann war mit seinem Auto in einem Fluss stecken geblieben und wurde von den Fluten mitgerissen. Er war auf das Autodach geklettert und trieb hilflos mit dem Wagen ab. Als Feuerwehrleute ihn an einem Tau auf eine Brücke ziehen wollten, verließen ihn die Kräfte und er stürzte zurück in die Fluten. Doch auf der anderen Seite der Brücke gelang es den Helfern ein zweites Mal, ihm ein Tau zuzuwerfen, und diesmal ging alles gut. Mit letzter Kraft klammerte sich der Mann daran fest und wurde endlich ans rettende Ufer gezogen.
Good afternoon and welcome to Kennedy Space Center for the Deep Impact Pre-Launch Press Conference. Our presenters for today, from my left is Orlando Figueroa, Deputy Associate Administrator for the Science Mission Directorate at NASA Headquarters. Omar Baez, NASA Launch Manager for Deep Impact at Kennedy Space Center. Chris Walsh, Director of NASA Programs, building Expendable Launch Systems in Huntington Beach, California. Rick Gramier, Deep Impact Project Manager from the Jet Propulsion Laboratory in Pasadena, California. Monty Henderson, Deputy Program Manager from Ball Aerospace and Technologies Corporations in Boulder, Colorado. And Joe Tombiola, United States Air Force Delta II Launch Weather Officer at the 45th Weather Squadron at Cape Canaveral Air Force Station. We will begin today's briefing with a few words from each of our panelists, and then we will go for questions. Orlando?
Thank you. Tomorrow, we take the next critical step in the life of an incredibly exciting mission that we hope will explore some of the most primitive bodies in our solar system. If successful, Deep Impact will reveal secrets about the origins of the solar system and perhaps the transport of materials essential to the formation of habitable environments and environments that could be suitable for the origins of life. I want to acknowledge the whole team, the Deep Impact team, for the tremendous effort in getting us to this point, and of course to the Kennedy family for their incredible hospitality in helping us to get here and hopefully setting us up for tomorrow. Deep Impact is the 8th mission in the Discovery program family. Discovery provides frequent flight opportunities for moderately priced missions for the science community to do investigations of focused areas of science in answering key questions in the exploration of the solar system. On July the 3rd of this year, after a 268-mile journey, Deep Impact will catch up with Comet Tempel 1, a comet that drops by our neighborhood every 5.5 years or so. Upon arrival, it will release an 820-pound impactor on its path to be run by it. Go figure. You know, going such a long way to drop an impactor and allow it to be hit by this huge body. While the mothership, in the meanwhile, is capturing the whole event through some of the most powerful cameras ever flown into space and instruments that will reveal the secrets of the chemistry and compositional fingerprint of the comet. Now, other NASA and non-NASA assets will be observing the event from afar. The Spitzer Observatory, the Hubble Space Telescope, the Chandra Observatory, and hundreds of amateur astronomers throughout the world will be watching at the same time that we are. It is very fitting that the orbital mechanics were just right for this event to occur on July the 4th. It's terrific, no pun intended, for such an impactful event to be captured on such a date. The world science community has been studying comets for a while. Certainly with spacecraft since the mid-80s, we have flown by them, we have observed them from afar, and this year we go with a home run, certainly with deep impact, and in January of 2006 with the return of samples from Comet Welt by Stardust, another discovery mission. This is a perfect example of what the NASA vision is all about. I wish all of us the very best, and we can only, in this business we're in, celebrate one step at a time. We have succeeded in building a terrific spacecraft. The Delta II team has made the launch of missions of this type look easy, but we all know that it's inherently very high risk. So we certainly pray for the best. And then we have 6 more months to get to our destination for the real deep impact mission to take place. Once again, good luck to all of us, and go deep impact.
Thank you, Orlando. We will now go to Omar Baez, NASA Launch Manager for Deep Impact, for some comments.
Thank you, Jessica, and thank you, Orlando. It's been a pleasure hosting the Deep Impact mission here at the Kennedy Space Center, and to be part of this wonderful mission. I remember the Launch Services Program started working this mission back in 1999, and it's been a long way to get here. There's been a lot of hard work put into it to make sure we have a great integration of the spacecraft with this launch vehicle to make this mission a success tomorrow. It's just the start of the journey tomorrow, and it's got a long way to go. But I just want to recognize that there was a lot of work that went behind the scenes here to get to tomorrow and to get to July the 4th. If you would roll the tape, I'd like to show some of the processing that we've done on the booster. It's a typical Delta II booster erection. This happened prior to early in the week of Thanksgiving. We put up the booster and 3 of the solid rocket motor, the GEMs. This booster is carrying 9 of the solid rocket motors. A lot of this work that I told you about is done by our analysts and engineers working in conjunction with Boeing and with the spacecraft folks. And a lot of hard work did go on. There was some, in fact, there was even some late trajectory work going on here, very late, and it's just a tremendous effort from the folks. These are just the remainder of the solids going up. They go up 3 at a time. We hoist them into the missile service tower and then roll it back around the vehicle and bolt up the GEM motors to the first stage. Shortly you'll see the second stage being rolled up and hoisted up into the tower, and you'll see the can roll up sometime thereafter with the deep impact mission, or the deep impact spacecraft within it. Here's the second stage. And along with this work I was telling you about, there's a lot of analysis that goes on because these spacecraft are custom built and one of a kind. There's some significant nutation time constant work, which is, for those that don't know, and there's very few people that do know what that is, it's sloshing of fluids within bladder tanks and how it affects the spin of a spin-stabilized spacecraft such as Deep Impact. And a lot of brain power and knowledge goes into those analyses to make sure we have a dead-on mission. This is the spacecraft in the tower, shortly to be uncanned and protected by its fairing halves. And this was work that went on through the holidays, through Christmas and New Year's. And it's a tremendous effort from the Boeing, NASA, and the spacecraft team. And with that, I'd like to turn it back to Jessica. That concludes this portion of the brief for us.
Thank you, Omar. We appreciate it. We will now hear comments from Chris Walsh, Director of NASA Programs, building expendable launch systems in Huntington Beach. Chris?
Thank you, Jessica. Boeing is pleased to be a part of this historic mission for NASA and JPL. And tomorrow at 1 47 in 8 seconds. We plan to launch a pretty standard Delta II, a Delta 7925. As Omar stated, that has 9 solids, and it also has a third stage, a solid rocket motor third stage. At liftoff, we'll have our main engine, Rocketdyne RS-27, firing, as well as the 6 of the 9 solids. The solids will fire for 63 seconds, and then we start a sequence where our 3 airlit solids will ignite, and then 1 second later, 3 of our empty solids will be jettisoned, and 1 second later, the last 3 will be jettisoned. The 3 airlit solids also fire for a little over 60 seconds, and they will jettison. And then we're powered just by our main engine till 4 minutes, about 4.5 minutes after launch, where we have main engine cutoff, or MECO. Seconds after that, our second stage will ignite, followed by fairing jettison. The fairing protects the spacecraft through the environment until we get to a low density of air. The thermal constraints go down, and we would jettison the fairing. We have a pretty short burn for our second stage burn. It's only 5 minutes. And then it's followed by a 15-minute coast. By that time, we're 24.5 minutes after launch, and we're over the west coast of Africa. We'll then fire again for a little under 2 minutes, our second stage, and we'll be basically over Africa at that time. After second stage cuts off there, we separate from our third stage in spacecraft, and our third stage will burn. It only burns for 87 seconds. It's a solid, as I mentioned earlier. So that 87 seconds is somewhat approximate. Then we will separate the spacecraft for a nice short mission for Delta, 34 minutes, 16 seconds after liftoff. We'll separate the spacecraft, and we'll be over the eastern side of Africa. Thank you, Jessica.
Thank you, Chris. We will now go to Rick Gramier, Deep Impact Project Manager from the Jet Propulsion Laboratory. Rick?
Thank you, Jessica. I'd like to start out by congratulating the team that made this all possible from the project viewpoint. First and foremost, of course, is Dr. Ahern, leading the science team, who's the principal investigator. The Jet Propulsion Lab, which provided the project management, as well as a very talented team of engineers and scientists. And finally, our system contractor, Ball Aerospace, who actually built and tested the flight system. This was a very talented team. It was quite an honor to work with them, and it took a lot of talent to get this put together. It's a very complicated mission. Now, to speak about the mission a little bit, as you got a briefing on that from Orlando, but I should probably mention that this is actually 2 spacecraft in one. We have what we call a flyby spacecraft, and we have an impactor spacecraft. These basically fly as one integrated flight system until approximately 24 hours into the 24 hours from encounter. At that point in time, we separate the impactor and then do a divert maneuver with our flyby. The impactor, with its automated systems, optical navigation, etc., and propulsion system, navigates itself into the path of the comet for the impact, while the flyby has adjusted its orbit so it can see the actual impact and formation of the craters, excuse me, and formation of the craters following that, which is the primary science. So if we could have the first picture, please. This is a picture of Dr. Ahern, principal investigator, with what we call the copper cratering mass. This is about 317 pounds of copper that we put in the front of the impactor spacecraft to actually form the crater. Now, at the time, we expect the crater to form anywhere from the size of a small house to the size of a football stadium, anywhere from 2 to 14 stories deep. The material was chosen specifically because we know that copper doesn't interact with water, and we can distinguish its properties rarely from the rest of the science data that's being collected as far as the actual pristine materials inside the comet, which is the primary science of the mission. Next picture, please. This is a picture of the impactor itself. As you heard from Orlando, this weighs about 820 pounds. As you can see, this is fully integrated right now, the impactor itself. And at the bottom is where the cratering mass is, and the electronics and propulsion systems are on top. This is a single-string spacecraft, unlike the flyby, which we'll now go to. Could I have the next picture? This shows you the flyby at the top being lowered down onto the impactor, which you just saw. The flyby we like to refer to as the mothership, and it weighs about 1,325 pounds fully fueled. What you see in the foreground is the instrument suite, the large telescope, the HRI, high-resolution instrument, as well as the medium-resolution instrument. And these are the ones that are used to actually view the impact itself and take the science data for the mission and beam that back to the stations on Earth, the DSN network stations. And then at the top you'll also see the high-gain antenna that provides the primary communication medium back to Earth, as well as the solar array panel, which is in the rear. Next, we have a little bit of a video clip on how this fits into the launch vehicle in the 9.5-foot fairing. As we said, it's on the 7925. Where you see this, the actual solar array itself is what we call deployed, or excuse me, not deployed. It's wrapped around the spacecraft, and then you see the impactor at the bottom there facing the third stage of the Delta rocket. And then if we could go to the next. Okay, this is the actual launch of deep impact animation, obviously. As you can see, and as Chris said, we fire the first set of solids off and then the second set of airlit solids. After that point, second stage, and we also take the fairing comes off, and third stage then spins up and ignites and sends us on our escape trajectory. As soon as we come off, our primary job here is to get the solar array deployed as quickly as possible. As soon as we do that, we begin to warm up for our systems, and we detumble the spacecraft with our reaction control system. And the first thing we want to do as soon as we can is get the solar arrays on the sun so that we're power positive. And then about 50 minutes after launch, 48 to 50 minutes after launch, we'll come in range of the DSN station at Canberra, Australia, where it'll pick up the first acquisition of signal and begin sending the health and status telemetry back to us in the mission support area, where we'll start checking the health of the spacecraft. Now if we could go to the next clip. The mission itself, as you heard, in deep space terms is rather short. 6 months time to get there. It travels approximately 268 million miles. And it's basically a direct trajectory to the comet. And you'll see in the animation that we actually, when we do release 24 hours out for the impactor spacecraft, it's optical navigation and control software takes over, and as I said before, places it in the path of the comet, while the flyby itself diverts and begins taking the science pictures. And the primary science is basically within about 800 seconds from beginning to end. And that concludes my portion of the briefing on the mission. Back to you, Jessica.
Thank you, Rick. We will now go to Monty Henderson, Deputy Program Manager from Ball Aerospace. Monty?
Thank you, Jessica. On behalf of the Deep Impact team, it's an honor and very exciting to be here at the Cape Canaveral area for launch. We're very excited about tomorrow and looking forward to it. I do have a short clip to show that kind of displays what we've been through since we've arrived here at the Astrotech facility here just outside base on October 16th. So if we could roll that clip, please. Okay, here we are pulling in the middle of the night. The spacecraft was shipped via air ride vehicle truck, and we're unloading in the airlock facility at Astrotech.
craning over to our transportation cart, mount it on, and removing the ESD bagging. We'll then move via the transportation cart onto what is our work stand, which is our stable platform, and deploy our solar arrays. You hear that snap. Of the solar array debounce mechanism. That's our solar arrays with the covers on. Now here, with the covers removed, we're checking the illumination of the solar panels, validating that each of the quadrants of the solar arrays are still functioning as we expect. We're installing the high gain antenna, which did not go down in did not ship on the spacecraft itself. So we're installing the high gain antenna here and affixing it to our gimbal. And this is our flight battery. We test with a test battery, and now that we are getting ready for launch, we've installed the flight battery, and we are charging that now as we speak to be kind of our power plant for the mission. Here we're bagging the spacecraft in preparation for move. We're leaving what's known as the payload processing facility at Astrotech. We're carrying it across the facility to what is known as the hazardous processing facility. And that is where we will fuel the spacecraft. So we're towing it across the parking lot. And here are our fueling team in their skate suits putting hydrogen propellant into the impactor and flyby propellant tanks. And now we've completed our fueling, and we're mating with the third stage of the Boeing rocket. And this is the mating platform as the impactor, which is that ring there, sits down on the deployment mechanisms on the third stage. And there we are mated with the third stage. Now we're putting a new ESD bag over the spacecraft again. We have a protective cover over the high gain antenna. Cover the solar array in preparation for canning. And you can see the can there on the left. The can is what protects the spacecraft during the transportation over to the launch site and the craning of the vehicle up to the top of the rocket itself. So we're installing the can. And it is on the bed of the truck. And here we are starting the drive, which was midnight on January 3rd. A very slow 2-mile-an-hour drive from the Astrotech facility to the launch site. I was in the follow-on car, and it was 5 hours, a very long drive. I'd also like to quickly walk you through our model here. Now what we have here is a quarter-scale model of the deep impact vehicle. This is full size. It's about the size of a standard SUV, 11 feet tall, 8 feet wide, about 5 feet deep. And what you see here is the impactor spacecraft in the deployed position. So essentially this is just at 24 hours out, we have released the impactor. So it's coming out of the bay from the flyby, kind of like a Russian stacking doll when it comes out. So the flyby is here coming out of its compartment. The impactor is here coming out of its compartment. The flyby spacecraft is here ready to divert out of the way of the comet. So the flight direction is this direction, and we are overrun by the comet coming here. Now, some of the interesting features on this, we've talked about the telescopes, the high-resolution imager and the medium-resolution imager. And at the trailing edge of the impactor is also an impactor targeting system, which is nearly identical to the medium-resolution imager. The high-resolution imager is the largest telescope ever flown into deep space. And with the 30-centimeter aperture, it can see 420 miles approximately. So sitting on top of our launch vehicle here, if we were to pull the fairing away and orientate it in the correct direction, we could potentially see Dr. Ahern on his boat down at the tip of the Florida Keys. So it's got incredible resolution, and the first of its type to ever fly into deep space. What we have here are our star trackers. After we leave the third stage and navigation out to encounter with the comet itself, we use stellar navigation. So it's in much the same way that the sailors did in ancient times, using triangulation between the three brightest stars in the field of view. We used the star trackers to navigate ourselves onto the impact trajectory with the comet. One thing, as we get closer to the comet, the reason comets are bright and you can see them in the sky is the dust and the illumination of the dust coming off of the comet as the dust is extruded from the ice as it's melting. And that dust is debris. And we have to shield the spacecraft from that debris so that we do not incur damage. Now keep in mind that the speed that the comet is approaching us is 10 kilometers a second, or almost 23,000 miles an hour, which is 20 times faster than any standard bullet flies. At that closing speed, a quarter of a gram, essentially the quarter of a standard M&M, will blow right through the spacecraft. So we have to shield ourselves as best as we can from the debris to protect our critical optics and our solar panels. And you'll notice that on a lot of spacecraft, you'll see that the components bolted to the outside. But for shielding, we have bolted them onto the inside of the flyby itself. The impactor also has layers of debris shields. So as it's overtaken by the comet, we expect to still get imagery up to almost 3 seconds prior to being overrun by the comet. We communicate. The impactor and the flyby communicate. The impactor sends imagery. As I said, it has a telescope, and it will send imagery via S-band communication. This is the S-band antenna. That it will be sending its imagery over from the impactor to the flyby spacecraft, and then it will packetize that telemetry with the images that it takes with its own telescope and send those back to the ground via our high-gain antenna. Now, the gimbal for the high-gain antenna has to have a pointing accuracy of 1/4 of a degree from 80 million miles away, which is where our encounter will happen. So the precision involved with this and many of the other items on the spacecraft are just almost mind-boggling to me, what we had to put together in order to make this mission accomplish. One final thing that I did want to mention, about a year ago, January 14th, we stopped our Send Your Name to the Comet campaign. And over 500,000 people registered on the website, and their names were etched onto a CD that has been mounted right along this ring of the impactor. So those of you that did put your name on the CD, it's mounted here, and it will go with the impactor as it's overtaken and essentially vaporized by the comet itself. Okay. Jessica, thank you.
Thank you, Monty. We'll now go to Joel Tumbiola from the United States Air Force Weather Office to give us a briefing on weather for tomorrow's launch.
Thank you, Jessica, and good afternoon, everyone. Well, despite the fact that I think I saw a couple umbrellas out in the audience, I do like our chances for having favorable weather for tomorrow's launch. Basically, ever since the Christmas holiday, we've been on a very good weather pattern. High pressure's been dominating Florida. We had above normal temperatures, sunny skies, and very little rain. And we're starting to get into a little bit more of a transition part right now where we're starting to get a little bit more into a Florida wintertime pattern. And what I mean by that is we haven't had a cold front in the area in a couple weeks, or we are tracking a cold front right now, which is now over the central part of the U.S., and it's slowly migrating to the east. As this happens, the high pressure that's been over Florida is being also pushed to the east. And when that does happen, the winds from the high pressure come off the ocean and create a few showers along the coast. That's what we had today, and we also will be monitoring that over the next couple of days. Again, it's just the winds coming off the ocean producing some isolated showers and clouds along the coastline. So that's basically the weather conditions we're expecting over the next couple of days. That cold front I mentioned is not expected to come through the state until Friday, and over the weekend our weather pattern is really going to shift from what we've been used to the last couple of weeks. But again, that will not be till a Friday, Saturday time frame. So again, over the next couple of days, we're just expecting a couple showers off the coast and some cloudiness that we will be monitoring. Specifically in terms of clouds, we'll have a couple cloud decks, one at around 25,000 feet, and we'll have another upper cloud deck at around 25,000 feet that we'll be monitoring with our weather radar and our weather aircraft. The winds will be out of the southeast. They've been out of the southeast, and they will start to pick up a little bit. They will be in the 14 to 17 knot range and start to increase a little bit as that cold front gets closer to us. And again, our temperatures will still be warm over another day or two. We'll be in the upper 70s, 76 to 78. by the weekend we'll be lucky to get out of the 60s, so we will see a change there. But again, in terms of weather conditions, just some isolated showers along the coast. And since we have an instantaneous window, chances are good that we won't have a shower right over the launch pad at that second in time. Yes, we need luck in this business. So we are hoping that we will not have a shower right over the launch pad at that particular point in time. And there's a greater than a 90% chance that we'll have a good weather tomorrow. So only a less than a 10% chance of one of these showers that we had, like this morning, moving right over the launch pad at that 1:47 p.m. time tomorrow. As far as the next day, our chances increase for showers and clouds. There's a 20% chance of having those clouds and showers in the area, basically the same setup. And again, going beyond Thursday, we'll expect a cold front on Friday, so our weather will deteriorate as we get to the Friday and to the weekend time frame. But hopefully we won't need that. Thank you very much.
Thank you. I appreciate it, Joel. We're going to begin with questions. Please limit to one question. I'll try to come back around if we have some additional time. As always, please state your name and affiliation, and with the panelists, let's go ahead and direct it to a particular panelist. I'm going to work my way from this side over to this side, so we'll start with Justin.
SpaceflightNow.com. I guess for Omar, you mentioned the late trajectory work. What was that work, and sort of what prompted that? And is that what precluded you from going on the first instantaneous launch opportunity tomorrow?
Yeah, that's a part of it, Justin. It's a good question. What happened is when we do two runs of trajectories in that integration flow. One is the DTO, which is done about 6 months out, and one is the BET, which is done shortly after the launch vehicle has been weighed, and we integrate some of the numbers coming off of the spacecraft mass into that. What we found is that the delta is a little bit heavy, and the performance model is showing lower performance than normal. So since we were out of a band that we were comfortable in as far as performance, we had to adjust some of the staging events with the second stage, how long it burns, how long it barbecue rolls, and etc. That imparted a little bit of change to the spacecraft's own trajectory work that they have to perform once they get to the point in space where we drop them off. The reason that we lost the first opportunity for tomorrow is the analysis that would have had to gone into to validate that earlier opportunity would have been pretty risky this late in the game, and it was decided to stand with the trajectory work that had been done, that had been tested, and that everybody had been blessed. So that's the reason we lost the first opportunity. From here on out, to the end of the window, we have opportunities on both the 95-degree azimuth and the 101-degree azimuth for every single day in the window.
Chris Cridewell from Florida Today for Rick. You said the word craters, and that may have just been maybe you misspoke, but you're expecting one crater from this impact. Is that right? Or?
Yes, one crater, only one, and you know, as Dr. Ahern points out, this is basically just a natural science experiment of what happens in space. They get hit by meteors all the time. The only difference being that this is an artificial meteor and that's man-made, and we only expect one. We just don't know how big it's going to be. Obviously, that's part of the science we're trying to get, is the actual properties of the comet nucleus itself.
Jay?
Jay Barbary with NBC, for anybody that wants it. At what point, orbital mechanics being what they are, do we reach that we do not reach July 4th? We delay 3, 4, 5 days. Are we still reaching there July 4th for an impact, regardless of when we launch, because the fact that the Earth is moving toward the comet?
Yes, that's correct. We always have impact on July 4th. The actual impact time itself may vary a little. Right now it's scheduled for somewhere in the 2 a.m.-ish time frame Eastern time. It'll still be 3rd of July over on the West Coast. But it's just adjusted by a few seconds. I wish. I wish we could travel that fast, yeah.
Marcia?
Yes, for Dr. Figueroa. It sounds complicated, this mission. Could you sort of compare it in complexity to other deep space missions perhaps people are familiar with? Granted, you're not bringing anything back, so that makes it easier perhaps, or could you just compare the complexity with other
Well, for our missions, everyone is unique and everyone has its own complexities. What adds a significant complexity to this mission is of course, the fact that there are two spacecraft. They're carrying very sophisticated instruments and cameras, and spacecraft that will be monitoring events that are occurring very quickly. And everything needs to be timed just right. And of course, we're going into a totally unknown territory, impacting, and we do not know quite exactly what we are going to observe, but we're certainly very excited about them. I mean, every one of the Discovery missions in particular, we consider them sort of a similar scope. In fact, that's what defines the cost cap. But every one has its own intricacies, and this one is pretty much at the top of the scale for Discovery class.
Stefano?
Stefano Corgan for the New York Times and Popular Mechanics. I was wondering what kind of an image quality you're expecting from the impactor, especially since you're getting so close to the comet, all of the dust. And is there a chance that you might actually lose the image because of damage to the optical system?
Well, obviously, it's a question of how close in the optics get sandblasted. If we're anywhere close to what we hope as far as the activity and the dust models and everything of what's coming off the comet, we expect to have up to 10 times better resolution of the comet nucleus than stardust returned. On the other hand, if we get blasted a little more heavily, then it'll back off somewhat, but we still expect it to be quite a high resolution compared to what stardust took of Welt 2. So really it's just a matter of, it's going to be taking those images all the way up until just prior to impact and transmitting those to the flyby spacecraft. So really it's a question of, it will still be taking the pictures, it's a question of when the optics get too sandblasted to make it visible.
Craig?
Craig Cavall with Aviation Week with one launch vehicle question and one spacecraft question. For the launch vehicle, do you have any downrange tracking assets that are added for key milestones this time?
We always have downrange assets for all-powered flight for the Delta II. For deep impact, we have the Otter, which is a shipboard downrange asset. And that will be off the western edge of Africa, and we also have Diego Garcia, which is picking up the spacecraft SEP. We have determined that that was not at all impacted by the tsunami. They are fully functional. For all our downrange assets, we've done data flows with all of them. All of them are operating fine, but they're all either in Africa or with the shipboard or Diego Garcia in the Indian Ocean.
One quick follow on the launch and then the spacecraft. The Otter's for third stage burn, or?
It's for SECO, our second restart of the second stage engine, and also for the third stage burn.
Okay, for spacecraft looking downstream, I know you're evaluating the idea of maybe a second comet as a flyby target later on. Depending on the assessments of downstream comets, by when would you like to be making a decision on whether you're going to go for a second comet flyby?
Boy, that's a difficult one to answer. Obviously, we're going to start that process after launch. Everybody's been focused on getting ready for launch, and we've obviously got some work to continue post-launch, but there is a certain portion of the team that's already evaluating possible other cometary targets after the conclusion of this primary mission. But of course that requires a process that we have to go through to do that. It also requires that we have sufficient fuel to reach it, which right now we think we would for some of the opportunities. So we'll begin working on that in the next few months.
We're talking about opportunities that would be 2, 3, 4 years away.
I believe they're more like 2 and 3 years away, yes.
At this point, we do have a couple of questions from another center, so can we go to JSC?
Thank you. This is Mark Carreau from the Houston Chronicle, and I have a couple questions that are related. I wonder if January 28th is still the end of this launch campaign, or it's another date. And just to follow up that, is there another target that you've selected already if you went past the 28th, or would you do that as the event occurred?
Currently, January 28th is the end of the launch window. We do have the Boeing folks working with us on possibly adding one day to that. That would require some deballast on the launch vehicle itself. So we have every reason to believe that we're going to get off by the 28th. I honestly can't see why we wouldn't. However, if we don't, we again have some possible opportunities, but that would require a lot more analysis. We do not have a primary or secondary target selected at this time. The flight system and the mission was designed specifically for this particular cometary body, and we would have to do a lot more of analysis in order to select a different target.
There are no questions from any other centers. Do we have some follow-ups, Justin?
A couple of spacecraft questions. I was wondering if you could tell us what is the mechanism that deploys the impactor? Is it a spring ejection, or what is that? And secondly, on the following release from the third stage, how soon afterward do the solar panels deploy? And when Canberra picks you up, will you know that? Will you have confirmation that the arrays are out?
You want to take the first one?
The impactor is ejected through explosive cutting of bolts, and springs release the impactor out. So it is a spring release.
And as to the second part of your question, the solar array is basically the first operation once the critical sequence is kicked off upon spacecraft separation. That's the first thing we do, is deploy the solar array so that we can use our reaction control system for the detumble. So that's done well before it comes up on Canberra.
Chris? Chris Cradler from Florida Today again for Monty. You put a lot of work into this. What's it going to feel like to see one part of your spacecraft smashing into a comet? Are you going to feel a little sad, or are you going to be excited?
No, I think everybody involved will be extremely excited. I mean, we built this to go and impact the comet, and when it all happens on the 4th of July, it will be this fantastic feeling of it worked, everything's done, and that the 5.5 years that we put into it were really worth it. We're very excited about it.
Jay?
Monty, you were saying you could see someone on a boat in Key West with your camera from here. Can it pick out a person about 300 miles away?
Yeah, it's got 1 meter resolution from 420 miles.
Marcia?
Yeah, Marcia Dunn, Associated Press for Mr. Henderson. What type of material did you use to make your shielding, and how thick is it on the spacecraft and the impactor?
That's a very good question, because we can't use thick shielding because of the prohibitive weight. So what we did was layers of thin copper shielding that allows, as it blows through, it essentially tries to break up the particle as it goes through the various layers of shielding. So I think we saw a picture that, like at the base of the impactor, it's a series of almost fins that are interlaced within the cratering mass itself. So that as debris is coming in, each individual shield hopefully breaks up the particle into smaller and smaller pieces. Well, for the cratering mass, it's a 5-layer shield.
What about the mothership?
Well, the mothership has...
How did you work that shielding? Is it the same material?
Yeah, and it is. And the aluminum structure itself also serves as a debris shield. And we have the hockey stick-shaped shield that's protecting our optics on the outside of the instruments themselves.
Greg?
Question on post-launch instrument calibration. When we were in with the spacecraft, we were discussing among members of the team there, looking at the moon and I believe Jupiter. Do all 3 imaging systems do that, or is there a different division of labor there in the calibration?
It's actually a split. Some do it with the moon. Others for the Jupiter watch, for example. That's more for the auto navigation software and optics to test out their calibration.
So the auto nav optics are different, or
no? The optics are the same.
there, so.
Okay, that's fine. The optics are the same, i.e. they use both the HRI and the MRI, but the actual processing of the data is different than if you're strictly taking the scientific data and calibrating to that. This is to also calibrate with what AutoNav thinks it will see within what we've bounded it with as far as its operating parameters.
From the Mission Director Center at Cape Canaveral, this is Delta Launch Control at T-minus 106 minutes and counting. The countdown is progressing very smoothly. There are some upper-level winds that the launch weather officer is keeping his eye on and making sure we're monitoring throughout the countdown. The launch team is not working any problems with the vehicle or the payload at this time that would delay today's planned launch. Liftoff is planned for the opening of an instantaneous window at 1:47:08 p.m. from Launch Pad 17B. Launching aboard a Boeing Delta II expendable launch vehicle, Deep Impact will blast a hole in a comet, allowing scientists for the first time to study what a comet is made of. The spacecraft is designed to launch an impactor, which is a copper projectile into the surface of Comet Tempel 1 on July 4, 2005. We are now very fortunate to have joining us Jim Kennedy, Director of the Kennedy Space Center. He's going to discuss a little bit of the mission and the work performed here at KSC. Thank you, Jim.
Good morning, Jessica, and thank you for an opportunity to be together. I want to start by thanking you and the PAO people for helping us tell the NASA story. The NASA story is such a beautiful story. Today's launch of Deep Impact is such an exciting mission, and we are so happy that you're here to help us tell the story. While this is all about a robotic mission, a most exciting robotic mission, I think it might be appropriate to reflect that 2 weeks from Friday we will be commemorating. We think about the fact that we have lost lives in pursuit of spaceflight. We had the Apollo 1 fire, Challenger, and then sadly the Columbia loss. And while we commemorate that every year and we learn from the lessons of human spaceflight loss, it is so exciting to me to reflect upon the fact that we have this beautiful balance of robotic missions, not human missions, but robotic missions that are exploring the universe. And Deep Impact is going to help us understand so much about comets. It's just an exciting day for all of Kennedy Space Center.
Well, the launch team has spent a long time getting up to speed for this mission and preparing. Can you tell us a little bit about what's gone on in preparation for this mission here at KSC?
I'd be happy to. It is all about a team. Indeed, it's about a team. At the Kennedy Space Center, we have this fantastic group of people that are organized in what we call the Launch Services Program. It's a couple of hundred people who start years and years ahead of a launch doing the detailed integration, the mission management, the engineering, the work necessary to bring all the pieces together such that we can have a launch like we're having today. So it is a lot about the Launch Services Program team under Steve Franz. So proud of those people and what they do. And then what they do is go out and make the team bigger. They contract with a launch vehicle provider. In the case today, it's Boeing, who has this phenomenally safe vehicle, a Delta II launch vehicle, which today will be the 63rd consecutive of a Delta II vehicle. And then the team also is composed of those people who bring to us the spacecraft. That spacecraft today is Deep Impact, and that team is made up of organizations like the Leadership Center, the Jet Propulsion Lab, who has had such a phenomenal run of tremendous, exciting space science exploration. They team with Ball Aerospace, they team with the University of Maryland, where the principal investigator for this, Dr. Ahern, an astronomer from the University of Maryland, is the PI that's going to help us understand this exciting science coming back from Deep Impact.
Wonderful. I think it's interesting that this is a wonderful mission as well, but we have had a lot of wonderful missions over the last year and a half. So can you talk to us a little?
Exploration of our universe. I think most of your viewers are aware that we currently have Spirit and Opportunity on the red planet as we speak. Vehicles that were designed to last 90 days, they're now celebrating their 1-year anniversary of exploring Mars. Recently, we sent a mission known as Messenger on a 5 billion mile journey to get to the planet Mercury. And for the first time ever, we will be orbiting Mercury 6.5 years from now. In the other direction of planets, one that is really current and exciting to think about is that Cassini was launched from right here on the shores of Florida 7 years ago to the planet Saturn, and we saw the beautiful graphics that came back as Cassini plowed through the rings of Saturn. And now, Friday of this week, a part of the Cassini satellite known as the Huygens probe that comes to us from the European Space Agency, an opportunity to team with other nations, in fact. Huygens probe is going to be plummeting into the largest moon of Saturn, Titan, to help us understand about the moon of one of the most beautiful planets in this universe. So those are just a few, but we have a long history of success, and I am so proud for the Kennedy Space Center team to be a part of this NASA industry team that is accomplishing such great science. National Space Station that we will do over the coming 6 years. Beyond that, the vision has a balance of human exploration and robotic exploration. What Deep Impact is doing for us today, what Spirit and Opportunity and Cassini and Messenger, what they have done for us in the past, is provide that exciting robotic look at this universe to help us understand what it's going to take for human exploration, and one day we will be sending people to these same planets that today are going robotically.
Well, thank you so much for taking a few moments to come over and talk to us. We appreciate that, and we're looking forward to a wonderful launch today.
We are indeed. Thank you, Jessica.
Thank you. At T-minus 100 minutes and counting, this is Delta Launch Control.
Okay, less than 20. Okay, copy that. We're going to drain 50 gallons back per. Open. Prop 2, take fuel flow meter number 1 mode to drain. Drain. Prop 2, take fuel flow meter number 2 mode to drain. Drain. Prop 2, take the fuel umbilical purge open. Purge is open. Prop 2, take the fuel fine load open. Fine load coming open. Okay, and Prop 2 report when the wet sensor goes off and the dry sensor comes on. Roger. Okay, we lost the wet sensor. I didn't even recognize it. I guess it was.
They've asked for all three to go to 65.
At T-minus 96 minutes and counting, this is Delta 95 minutes and counting. This is Delta Launch Control.
And when the vehicle fuel tank pressure is 5 to 8 psi, prop 1, open the vehicle fuel tank pre-push rapid vent. Roger.
That green balloon. Down to 94.
This is the LWO with the L-minus 125-minute weather update. On your closed-circuit TV, you should have a southeastern United States satellite. You can see that we do have a little bit of cloudiness over the peninsula. It's a little bit more pronounced out to the east of us. The big thing about looking at the large satellite picture, you can see that large amount of cloudiness to the west of us as that front develops in the Midwest that'll be coming through our area. Looking at the close-up shot, 1 nautical mile resolution, you can see the Cape itself is virtually cloud-free. We have clouds to the west of us. Those clouds that are to the east of us are actually very low tops, and whenever you look at the radar, you can see that there's virtually no precip associated with any weather constraints. Looking at the upper level graphic, you can see a combination of both low resolution, high amplitude, or high resolution amps, and 50 megahertz balloons. This covers a period of approximately an hour and a half. You can see with all three systems we're getting a lot of persistence. We do have double maximum up 45,000 and around 55,000. This is associated with overlapping tropospheric tropopause leaves over the southeastern United States. The higher one is associated with the tropical tropopause. The lowest is associated with the Arctic tropopause. I don't know if it's a good thing, but whenever these overlapping leaves in the upper atmosphere, they're very slow to change, so I don't think you're going to see a lot of variation balloon to balloon. Looking at the peak winds, this is the Tower 2 at southeast center at 90 feet. You can see they've increased a little bit as we started to heat up, but still remain between about 10 and 17 knots, and I think that'll persist through the remainder of the day. Do look, if you get into a scrub condition, they should increase to about 15 to 20, possibly a little bit higher tomorrow afternoon. But this constraint today of 10 to 15 knots is well below the allowable limit of 33 knots in that direction slot. As you can see, the direction is really persistent the last 3 to 4 hours. They remain right in that slot between 135 degrees and 195 degrees, which is the slot for the maximum allowable is 33 knots. RC, this is the LWO on channel 20. Go ahead. Do you hear that echo now? RC, can you hear an echo on channel 20?
Minutes and counting. This is Delta Launch Control. The tower at Launch Pad 17B was rotated away from the vehicle this morning, and tower rollback was completed at 6:33 a.m. We began the terminal countdown at the T-minus 150-minute point. Prior to that time, the pad was cleared so that fueling of the Delta's first stage with about 10,000 gallons of highly refined kerosene could begin. It generally takes about 20 minutes for the fueling to be completed, and the fueling was completed on time. We will now go to a tape of the Delta vehicle that will carry Deep Impact into space consists of several major assemblies. The first stage, which includes 9 strap-on solid rocket motors, the second stage, the third stage, and the 2-piece composite payload fairing encasing the Deep Impact spacecraft on board. The Delta II rocket is 125 feet tall and 8 feet in diameter. The payload is shrouded in a stretched 9.5-foot fairing. The first stage main engine has a liftoff thrust of over 200,000 pounds, and each of the 9 strap-on solid rocket motors has a sea-level thrust of 97,000 pounds. The main engine and the solid provide a total liftoff thrust of nearly 800,000 pounds. Seen here early in the morning is the tower being rolled back away from the Delta II vehicle prior to loading of the highly refined kerosene. We are now back live with pictures of the Delta II vehicle at the pad. Everything is continuing to flow smoothly today, and launch remains scheduled to occur on time at 1:47 T-minus 79 minutes and counting. This is Delta Launch Control.
Verified. Take PSD purge press open. Open. And verify PSD purge pressure is 400 plus or minus 25. Verified. Purge press closed. Closed. Prop 2, verify the following LOX valve positions. Storage tank press closed. Closed. Storage tank vent open. Open. Fine load closed. Closed. Rapid load closed. Closed. Trim closed. Closed. Topping closed. Closed. Fill closed. Closed. Debris open. Open. And prop 1, report engine section temperature increase when it occurs. Roger. And we do have an increase in engine section temperature.
Copy. OSM, report go for cryo loading.
Go.
And LVD, report go for cryo loading.
Go. Blackwell lower flow switch is actuated.
3 minutes into flow. Roger.
At T-minus 73 minutes and counting, this is Delta Launch Control. A short time ago, we heard Launch Manager give the go for cryogenic loading of the first stage. Servicing of the liquid oxygen into the first stage began at 12:03:01 p.m. this afternoon and takes about 1 hour. There is a limit of 168 minutes during which launch can occur after the initiation of liquid oxygen servicing. The temperature of the liquid oxygen is about 297 degrees below Fahrenheit 0, which means it continuously boils. Topping off is required to maintain a required mass of the fuel. At this time, the launch team is not working any issues associated with the Delta vehicle or the spacecraft. The launch weather officer is keeping an eye on some upper-level winds that are causing a concern, but they will continue to monitor those throughout the countdown and send up weather to 69 minutes and counting. This is Delta Launch Control.
Six minutes into flow. Seven minutes into flow.
At T-minus 65 minutes and counting, this is Delta Launch Control. Everything is continuing on schedule for today's launch of the Deep Impact spacecraft aboard a Delta II rocket. The launch team is not working any technical issues that would be an on-time launch at 1:47:08 p.m. Eastern this afternoon. Joining me now is Monty Henderson, Deputy Program Manager at Bell Aerospace. Thank you for joining us today.
Thank you, Jessica. It's good to be here.
Thank you. We have a short video of the spacecraft being processed that we are going to play now that Monty can describe the scenes on the tape as we view it.
Okay. Okay, this is since we've arrived at the facility down here. This was October 16th when we rolled in. We're pulling ourselves out of the shipping container here. That's the spacecraft bag and the ESD bag. We're mounting onto the transportation cart. We're now actually on our work stand, pulling the ESD bagging off. I'm sorry, there. Now we're moving over to the work stand. We're deploying our solar arrays here. Listen for the snap. Now, Excellent. And that's deploying the solar arrays, so we can work with those. We'll take those covers off here in just a sec. During all of our testing, we were using a non-flight battery, so we were not putting cycles on the actual flight battery. So here we're swapped out the non-flight battery, put the flight battery in. Now we're preparing the ESD bagging over the spacecraft. We've completed all of our testing in what's known as the payload processing facility, and now we're preparing to move. So here we're towing it out of the anteroom outside of our clean room, pulling it across, and just so you think I actually work for a living, I am pulling one of those straps there. And we are moving it into the hazardous processing facility. Here we've got one of our fueling team in his scape suit filling the 2 propulsion tanks, one on the flyby, one on the impactor, with the hydrazine propellant. Now we've completed the fueling, and we are craning onto the top of the Boeing 3rd stage. And here this is our mating surface between the deep impact spacecraft and the 3rd stage. And those are the ejection springs that separate us from the 3rd stage. So there we're fully mounted and integrated with the 3rd stage. We're putting additional ESD bagging back over now in preparation for our shipment over to the launch pad. So we're covering the solar panels with the appropriate ESD bagging. The 3rd stage is already on the shipping truck. This is the can, so this is the protective shell that we'll be shipping in. So they're going to crane the can on top of our spacecraft and around our spacecraft. And then we will be ready to take the very long and slow drive over to the launch pad. So here the truck has come in,
15 minutes in the floor.
At T-minus 57 minutes and counting, this is Delta Launch Control. Joining me this afternoon is the NASA Mission Integration Manager for Deep Impact, Mike Stelzer. Thank you for joining us today. We appreciate you taking the time to come over.
Good afternoon, Jessica. Thank you. It's a pleasure to be here with you.
Great. We're going to now be showing a tape of the processing flow of the Delta rocket, and Mike will provide a description of the events as we go through it.
Okay, this is the arrival of the different launch vehicle pieces for the Deep Impact mission. This is the first stage coming out to the Complex 17, and you're seeing the erection of the first stage out there at the launch pad. This happened a little bit before the Thanksgiving holidays. Up until that point, if you remember back in the October time frame, after the hurricanes cleared, we had a stack up at both pads with the GPS mission, Air Force GPS mission, and the NASA SWIFT mission. So we actually put some processes and paper in place to be able to go off either pad and kind of waiting to see which one cleared. So we ended up going to Pad B. What you're seeing here is the solids coming out to mate up with the first stage. The Deep Impact mission, because of its performance needs to catch the comet, we've actually put the maximum amount of solids that we can fit around a Delta II. So we're going to see 9 solids in this footage going out to meet up with the first stage. So that's gives this mission an extra boost to get off the Earth and on its way towards rendezvous with the comet. The solids are lifted into the mobile service tower. We put them out there 3 at a time. And then we actually roll that mobile service tower forward and then mate the solids around the first stage. Now, once we get the solids in place, the next step is to bring out the second stage. This is what you're seeing at this point. The aerojet nozzle is out to the left. We've filled up the tanks on the second stage earlier in the week and filled them up just as much as we can, because on this mission we're actually going to do 2 burns of the second stage. The first one is going to help to put the vehicle into orbit around the Earth about 90 miles up, and then we'll let it coast over most of the Atlantic Ocean, and just off the coast of Africa we're going to light up that second stage again and take us out of Earth orbit towards the comet. We also have a third stage to give it that extra boost to catch up with the comet, and we'll light that off over the coast of Africa, and that'll provide it the final boost to get the spacecraft on its way. This is a picture of that integrated third stage and spacecraft coming out to the launch pad. We do that in the early hours of the evening when we have the calmest winds and calmest weather. That assembly as it comes out to the launch pad, as you can see, we've got it wrapped up with several layers of protection. The outer bag on the outside. This is a shot of that protective cover coming off the bottom of the container. It's carefully lowered into place and bolted down with that bag. We have a protective canister, and this is a shot of them removing that canister. And final protective cover for electrostatic discharge. So that's carefully raised off, and we're getting the first shots of the satellite out there at the launch pad. You can see as the can clears the communications antenna that the satellite will be using for communication back with Earth. Following that, we do about 3 or 4 days of test and check out on both the third stage and the spacecraft to make sure it's working properly with the rocket. And we bring the fairing over and encapsulate the spacecraft and third stage with the fairing. It comes over in 2 halves. This is a shot of them carefully lowering it into position, and kind of shows how snugly the deep impact spacecraft fits with inside that fairing. After the first half is placed, they'll bring the second half over.
For the vehicle processing, that's very helpful. What were some of the challenges in getting this vehicle prepared for launch today?
We've been working on this mission since we turned it on 2.5 years ago, and it's been real exciting. Obviously, performance and getting the spacecraft to the right targets in space so that our counterparts with the Jet Propulsion Lab and with Ball can guide it on towards the comet. So working the trajectory solutions out and having those available has been a challenge. Also, we have a little bit different configuration between the spacecraft and the third stage. The propellant tanks within the spacecraft are in line, so we've done a lot of additional analysis and testing for this new configuration to ensure that we're not going to have any issues, and that it'll fly during the third stage flight and be just fine. So.
Well, we're looking forward to a great launch today. Thank you again for joining us. We appreciate it.
Thank you, Jessica.
At T-minus 51 minutes and counting, this is Delta Launch Control.
"23 minutes into flow. 24 minutes into flow.
%. Rapid load coming closed. Fill coming closed. Copy and prop 2 report 99% locks float switch pickup upon occurrence. Roger.
At T-minus 48 minutes and counting, this is Delta Launch Control. At this point in the countdown, the launch team is not working any technical issues with either the vehicle or the deep impact spacecraft that would prohibit us from an on-time launch at 1:47:08 p.m. Eastern. The launch weather officer continues to watch some upper-level winds that are causing us some concern. They will keep the launch team updated as well as send out weather balloons to provide the most up-to-date information to the launch manager. The Delta vehicle that will carry deep impact into space consists of several major assemblies. The first stage, which includes 9 strap-on solid rocket motors, the second stage, and the 2-piece composite payload fairing encasing the deep impact spacecraft on board. The Delta II launch vehicle is about 125 feet tall and 8 feet in diameter. Deep impact will blast a hole in a comet, allowing scientists for the first time to study what a comet is made of. The spacecraft is designed to launch an impactor, which is a copper projectile, into the surface of Comet Tempel 1 on July 4, 2005, when the comet is 83 million miles from Earth. One hope of the mission is for scientists to learn whether comets exhaust their supply of gas and ice into space or store it inside. Creating a crater in a comet is also expected to teach researchers how craters form and some information on how a comet or asteroid would be deflected if needed. At T-minus 47 minutes and counting, this is Delta Launch Control.
%, A and B, topping coming closed. Topping closed. Copy. Timer report locks flow time to 100%.
26 minutes, 42 seconds. 26:42.
Timer report UTC clock time.
17:30:22.
17:30:22.
Prop 2, maintain lock storage tank pressure through launch.
Roger.
Prop 2, activate and display record on change list for engine underscore start.
Roger.
Okay, activated. Prop 2, cycle the vehicle lock fill and drain valve closed, then open 2 times and verify fill and drain is open afterwards.
Roger. Coming close, lock, fill, and drain. Okay, good time. Coming closed, coming back to open. Good open, coming back to close. Closed and back open. And we look good.
Copy. Prop 2 takes locks, load, timer, enable off.
Coming off. It's off.
LCDR report clear to pressurized vehicle locks tank to check relief and establish VE locks bleeds.
And you're clear.
Copy. Prop 1.
At T-minus 45 minutes and counting, this is Delta Launch Control. Joining us now is Principal Investigator for the mission, Dr. Mike Ahern from the University of Maryland. Good afternoon. We're glad you could join us.
Thank you, Jessica.
We now have a short animation about the mission. If you would speak to that for us and let us know what's going on.
We'll start out with you seeing the spacecraft sitting atop the Delta II launch vehicle, and it's inside the fairing. Here you see the impactor nestled up inside the flyby spacecraft, and now we're going to fade away and back to the entire rocket and a launch shot as the first stage rocket goes up, and here the solid rocket boosters are jettisoned, and the last 3 solids are fired and then jettisoned. Second stage is dropped. Third stage is going. We start spinning for the solid rocket to boost us on the last little bit. And here we have suddenly jumped 6 months, and now the spacecraft is approaching Comet Tempel 1. It's a very elongated body of dirt and ice, would fit inside Washington, D.C., and here comes the spacecraft approaching the comet, turning to look at it. And here comes the impactor being released. The way we're going around the sun, the comet is actually overrunning the impactor, although in this picture it looks like the impactor has been fired at the comet. And the flyby spacecraft has to slow down a little bit so that it has a window after the impact here in order to watch what is going on. The size of this crater is very uncertain. We can't predict how big it will be. And
At T-minus 35 minutes and counting, this is Delta Launch Control. The countdown is progressing smoothly for the on-time launch of the Deep Impact spacecraft on a Delta II vehicle at 1:47:08 p.m. Eastern. However, the launch weather officer is continuing to monitor the upper-level winds, and the most recent balloon has shown an increase in those winds. So the team will continue to monitor those, but they are beginning to become of increasing concern for the liftoff today. Loading of the super cold liquid oxygen on the first stage began on time today at 12:03:01 and should be completed in about 20 minutes. Second stage helium and nitrogen pressurization is now reported to be complete. These gases are used for a variety of functions in the second stage propellant and attitude control systems. Slew checks or steering checks of the engines will begin at the T-minus 30-minute mark. The first and second stage hydraulic systems have been turned on so that the launch team can test the gimbal systems used to steer the rocket during flight. The gimbal systems swing the rocket nozzles of the engine to change the angle of thrust, which steers the rocket. These checks take about 8 minutes. The launch team is not working any technical concerns with the Delta II vehicle or the Deep Impact spacecraft. In just a few minutes, the NASA launch manager will receive an updated assessment from the weather officer about the winds expected at liftoff time. At T-minus 33 minutes and counting, this is Delta Launch Control.
On. FSE, HPU, on. On.
And this is the LCDR. The following personnel report ready to continue with the countdown on Channel 1. ATC-3.
Ready.
SSC.
Ready.
SCM.
Ready.
GE.
Ready.
SSP.
Ready.
TM2.
Ready.
ATC-2.
Ready.
Spectre 6.
Ready.
BP.
Ready.
FMA.
Ready.
QAM-3.
Ready.
QAM-2.
Ready.
FSC.
Ready.
TM1.
Ready.
DST.
Ready.
And RC.
Ready.
T-minus 30 minutes.
TM2 reports second stage hydraulic return pressure.
65.
FSC, slew limits on.
On.
SSC, slew limits on.
On.
TM2, activate record on change for jet response.
Activated.
FMA and RIFCOM, set up for flight slews.
Roger.
SSC, hydraulic external power to on.
On external.
SSE, hydraulic internal transfer to run.
Active. Complete.
Timer reports second stage hydraulic pump turn on time.
1747.36.
1747.36.
TM2 reports second stage slews as received.
Roger.
TM1 report first stage slews as received.
Roger.
Timer monitors second stage pump run time.
Roger.
FMA on your mark. PD2 on.
3, 2, 1, mark. Beginning coast slews. Jets 1 and 4. 3 and 6. 1 and 6. 3 and 4. Jet 2. And Jet 5. Pitching up. To the stop. Returning to center. Center. Pitching down. To the stop. Returning to center. And center. Yelling right. To the stop.
At T-minus 27 minutes and counting, this is Delta Launch Control. The team is coming slew checks of the second stage, and in just a few moments we'll be moving to the first stage slew checks, which will be checking the gimbal systems to swing the rocket nozzles of the engines to change the angles of thrust which steer the rocket. All of these checks take about 8 minutes. Second stage slew checks were just complete.
Load release verified. Stand by for release of the hold.
Cycling LOX tank vent.
At T-minus 4 minutes and holding, this is Delta Launch Control. We just came out of a scheduled built-in 10-minute hold. We are awaiting final status checks from NASA Boeing launch controllers and deep impact officials to make sure we are ready to proceed. All appears to be continuing well in the count, and we are moving toward the last few moments in the countdown. We will now go to a shot of the Deep Impact ground station. This is where the Deep Impact test team is located, giving commands to the spacecraft during countdown, assessing its readiness for launch, and troubleshooting when necessary. It is located at the Astrotech Payload Processing Facility, just west of Kennedy Space Center. At T-minus 3 minutes and counting, this is Delta Launch Control.
T-minus 3 minutes.
OSM, third stage S&A permit closed.
Closed.
SSE, third stage S&A arm.
Arm on.
Prop 1, vehicle fuel tank press open.
Open.
Prop 1, vehicle umbilical purge open.
Open.
FSC, bat 1 heater control exit.
Exit.
Battery 2 control exit.
Exit.
NSE, report spacecraft is go.
Spacecraft go.
At T-minus 2 minutes and counting, this is Delta Launch Control. We just heard a go for spacecraft to go to internal power. We expect to hear that the first stage oxygen vents will be closed, allowing the first stage to pressurize.
Top to 100%.
We just received the final go for liftoff today at 1:47:08 p.m. Eastern.
External. T-minus 80 seconds. RCO report range go for launch. Range go. LCDR, you are go for launch. Roger. T-minus 70 seconds. SSC. Hydraulic internal. Internal. T-minus 60 seconds.
T-minus 60 seconds, just seconds away now from the beginning of the deep impact 6-month journey to impact the Commel Temple 1.
T-minus 45 seconds.
CLCDR 17B, launch enable flight. Flight. ATC 3, main power disable on.
On. T-minus 35 seconds. Hydraulics go. T-minus 30 seconds.
T-minus 30 seconds, everything is go at this time for the launch of deep impact. T-minus 20. T-minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of a Delta II rocket carrying deep impact, NASA's journey to unlock the mystery of the solar system's origin.
Up on T plus 36 seconds, we are now supersonic. Vehicle now passing an altitude of 3 miles, downrange distance 13 miles, and coming up on 2,000 miles an hour. First stage performance still looking good, and we have exceeded max Q. All ground start motors have tapered off, and we have reached burnout. And the air starts have ignited, and all 6 ground start motors have jettisoned. See the normal level of disturbance after solid motor jettison, and that has damped out nicely. We're now passing T plus 86 seconds into the mission. Correction, air start solid motors all burning symmetrically, and they've passed their peak chamber pressure, coming up on T plus 105 seconds. Stage system still looking good. Now passing an altitude of 19 miles, downrange distance 45, and a velocity of over 4,000 miles an hour. Main engine and verniers continue to burn well, good chamber pressures there, and we are tapering off, reaching burnout of the air start motors. Jettison. All 3 air start motors have jettisoned. And we have pressurized the LOX tank. We have reset the relief reset. We can confirm a slow increase in LOX tank pressure, now passing T plus 150 seconds. First stage performance still looks good. Main engine and verniers still burning well. Nice good chamber pressure there.
Everything continues to look good with the deep impact payload on board. The 9 solid rocket strap-on boosters have been jettisoned, and the deep impact spacecraft is on its way to catch up to Temple 1 in July. We are now hearing Boeing's Mark Levine in the NASA telemetry lab, where real-time telemetry from the vehicle is coming in from the downrange tracking stations.
Data levels. Coming up on T plus 200 seconds. Now passing an altitude of 44 miles and a velocity of 8,000 miles per hour. Main engine and verniers continue to stay at the levels they should be, burning well. Coming up on T plus 230 seconds. First stage continues to look good. First stage data levels are where they should be. Passing T plus 245 seconds. Next event will be float switches followed by a MECO. Float switches have come in, and we have enabled MECO. There's MECO. Main engine has cut off. Both verniers still running well under tank pressure. And there's MECO, and 1-2 step. We've separated the stages. It is looking good. Second stage is just ignited. Chamber pressure coming up, looking good. There goes the fairing. We've unlatched, 1, 2, 3, and jettisoned.
The first stage cutoff took place, as well as first and second stages separated, with second stage ignition occurring moments later. We also saw the fairing cover protecting the deep impact spacecraft jettisoned about 4 minutes and 56 seconds into the flight. The second stage will continue to burn until nearly 10 minutes into the flight, when the second stage cuts off for the first time. The vehicle then coasts for about 16 minutes before the second stage is restarted.
A little over 13,000 miles per hour. Second stage data looking good. Thrust chamber pressure is where it should be. Taking a quick look at the MECO data. That is the first stage performance. And we show a burnout velocity at MECO, taken at MECO, at about 40, a little bit less than 40 feet per second, lower than nominal. Not a problem with that. That'll just mean the second stage will burn a couple of seconds longer. Coming up on T plus 400 seconds, second stage continues to perform well. Coming up on T plus 420 seconds, second stage continues to do well. We have locked up on Antigua data at this time, and the data quality is very good from the vehicle. Now passing an altitude of 90 miles, downrange distance 932 with a velocity of coming up on 15,000 miles per hour. have a liftoff time, range liftoff time of 18 hours, 47 minutes, 08.571 seconds. And that's in GMT, of course. Second stage continues to burn well. We're almost at the helium reg blowdown phase of second stage operation. Helium sphere pressure's coming down nicely. Chamber pressure looking good. We're less than a minute away from an expected SECO 1. Now passing an altitude of 93 miles, downrange distance 1,267 miles, and a velocity of 16,300 miles per hour. Data quality continues to look very good from Antigua. We are moments away from SECO 1. There's SECO. Looks like we did burn a little bit longer than the expected BET burn, and that's fine. We're still well within the 3 sigma. And it looks like we have reached orbit. Now passing T plus 600 seconds. The quality continues to look good. The vehicle has entered a coast mode. The computer shows us to be maybe 6.5 seconds longer than the expected BET time. And our height of apogee shows it at 90.28 nautical miles. Height of perigee, 89.95 nautical miles. And an inclination of 29.735. Those numbers are within a half a mile of the predicted orbit. Even better. And while I was talking, the CRDs were commanded off.
Everything is continuing to look good with the Delta II and the spacecraft. It looks like it's within a half a mile of its intended orbit, which is exactly per the launch team. We we just had second stage cut off for the first time, and the vehicle then coasts for about 16 minutes before the second stage is restarted. The second stage will be restarted at T plus 24 minutes and burn for about 1 minute and 35 seconds. We will now show replays of the deep impact launch just moments ago.
Hanging on to the data here, we can see it through an occasional noise burst, and we're now passing, correction, we're coming up on T plus 720 seconds, a little more than 12 minutes from launch. There we go. Looks like we have LOS from Antigua. Thanks for the ride. Okay, flight commentary is back with you. Looks like we made a successful orbit. We're now in the initial parking orbit, a nice circular orbit. We have a telemetry coverage gap now. About 7 more minutes to go as we fly over the Atlantic, and we'll pick up the vehicle on the other side. At that time, commentary will continue. Okay, flight commentary is back with you, and we can confirm our data is locked up, and we are receiving our signals from Ascension Island. So it's still in a coast mode. And we can confirm our roll, pitch, and yaw rates have come in. Those are the programmed rates, and they will soon be nulled out. We're seeing normal RACS jet activity as the vehicle maintains its attitude and holds the, there we go, we just switched off our programmed rates. Now passing T plus 1350 seconds. Data quality looking very good from Ascension. Our next event we're looking for will be the ullage jets coming on to settle the propellants for the upcoming burn. And that's a little bit less than a minute from now. Coming up on T plus 1400 seconds. All those jets have come on. The event we're looking for is the hydraulic pump command to on. Data quality continues to look good. Hydraulic system and return pressure came up. Actually, the system pressure came up, return pressure went down as expected. That will de-spin the third stage and spacecraft assembly.
The third stage is burned out, and we are standing by for the next event, which is spacecraft separation, in about 4 minutes.
Picking up a bit more noise on our third stage data. Still receiving third stage data, although it's a bit noisy. And I was trying to pull up a SECO 2 orbit page for you. I'll have that momentarily. Like our data has cleaned up here at the ground station. Okay, looks like I can't find the SECO-2 orbit data due to the our data dropouts. Once again, we are expecting a D-spin operation on the third stage. And back to the SECO-2 data, it's just not available at this time in real time, so I do not have a SECO-2 orbit. Coming up close to T plus 2,000 seconds. That's a little more than 33 minutes into the flight. Expect to pick up our telemetry over the Hardebeerstuk station momentarily. At the moment, we're seeing noise. Data has miraculously cleaned up. Thanks a lot, guys. We're expecting Yo deploy momentarily, less than 10 seconds. There we go. There we go. We can confirm a D-spin. A little burst of data. And yes, we have it, folks. Spacecraft separation. That did come in on time. We were a little bit delayed in reporting that, but it looks good.
We have successful spacecraft separation. Moments later, the hinged solar panels will unfold and the spacecraft will fire its thrusters to orient the solar panels toward the sun. About 15 minutes later, the antenna at Deep Space Network Complex in Canberra, Australia will acquire the deep impact signal.
Data quality is looking very good now from Hardebeerstuk.
Countdown zum großen Knall. Vor wenigen Minuten hat die NASA die Mission Deep Impact gestartet. Mit der Trägerrakete wird eine Raumsonde ins All geschickt, die ein riesiges Loch in den Kometen Tempel 1 sprengen soll. Erstmals will die NASA ins Innere eines solchen Kometen sehen. Das galaktische Monster aus Eis, Gestein und gefrorenen Gasen ist älter als das Sonnensystem und rast mit 37.000 Stundenkilometern auf seiner Umlaufbahn jenseits des Mars durchs All. Kometen enthalten organische Verbindungen und man nimmt an, dass sie eine bedeutende Rolle bei der Entstehung des Lebens auf der Erde gespielt haben. Deep Impact muss 6 Monate reisen, bis es in 130 Millionen Kilometer Entfernung auf den Kometen treffen kann. Ein Teil der Sonde wird sich dann in die Umlaufbahn von Tempel 1 manövrieren und am 4. Juli, dem amerikanischen Unabhängigkeitstag, durch die Aufprallgeschwindigkeit einen mehrere 100 Meter großen Krater in den Kometen Tempel 1 sprengen. Weltraumteleskope und die Hauptsonde selbst beobachten und analysieren die Explosion. Die Wissenschaftler versprechen sich davon neue Einblicke in die Entstehung unseres Sonnensystems.
Am Himmel zieht einsam der Komet Tempel 1 seine Bahn. Sieht aus wie eine Kartoffel, nur dass die Kartoffel 6 Kilometer lang ist. Ein ziemlich hässliches Ding, ein Haufen kosmischer Dreck. Nur wenn er alle 5,5 Jahre in die Nähe der Sonne kommt, schmilzt er ein bisschen und bekommt einen schönen Schweif. Zur Zeit rast er mal wieder in unsere Richtung, aber diesmal blüht ihm was. Die NASA schmeißt ihm einen kühlschrankgroßen 370 Kilo schweren Brocken Kupfer in den Weg. Und wenn die zwei Objekte zusammenstoßen, gibt es ein Riesenloch auf Temple 1, durch das neugierige Forscher in das Innere des Kometen und damit tief in die Vergangenheit unserer Galaxis schauen können. Ausgerechnet in einer Zeit, in der wir Menschen noch ängstlicher als sonst fragen, was diese gewaltige Natur noch alles im Schilde führen mag gegen uns arme, schutzlose Würmchen hier unten auf unserem schönen blauen Planeten. Deep Impact, so heißt die Mission, startete heute, berichtet Hildegard Werth.
Den Namen der Raumsonde hat sich die NASA in Hollywood abgeguckt. Deep Impact inszeniert die Gefahr aus dem All. Ein Komet auf Kollisionskurs zur Erde. Tapfere Astronauten versuchen, das kosmische Geschoss zu sprengen, vergeblich. Mit der Raumsonde Deep Impact wollen die Forscher nun den Spieß umdrehen. Sie fliegt zum Kometen Temple 1, um dem ein tiefes Loch zu verpassen. Am 4. Juli ist es soweit. Das Mutterschiff schickt ein 370 Kilo Projektil auf Kollisionskurs. Mit fast 37.000 Stundenkilometern sollen die ungleichen Brocken aufeinanderprallen.
Natürlich ist das Hauptziel der Mission zu verstehen, was Kometen eigentlich sind. Aber was wir über den Kern des Kometen lernen, ist genau das, was wir wissen müssen, wenn wir eines Tages gefährliche Kometen von der Erde weglenken wollen. Man muss wissen, wie der Komet reagiert, wenn man ihn beschießt. Es wäre fatal, wenn er zum Beispiel in 10 Teile zerbräche und alle würden auf die Erde fallen.
Deep Impact soll einen 100 Meter großen Krater in den Kometen schlagen. Dabei wird die Oberfläche abgesprengt. Was zum Vorschein kommt, ist jungfräuliches Material aus der Anfangszeit des Sonnensystems. Temple 1 ist ein alter Bekannter der Astronomen. Sein Kern dreht sich alle 41 Stunden um die eigene Achse. Die Forscher wollen versuchen, ihn genau an seiner Breitseite zu treffen. Seit seiner Entdeckung im Jahr 1867 umrundet Temple 1 die Sonne und hält dabei sicheren Abstand zur Erde.
Durch den Beschuss wird die Umlaufbahn des Kometen verändert. Wir haben sogar berechnet, wie stark. Also, die größte Annäherung des Kometen an die Sonne beträgt ungefähr 200 Millionen Kilometer. Diese Entfernung werden wir um 100 Meter verändern. Um höchstens 100 Meter.
Keine Gefahr also für die Erde. Deep Impact fliegt in 6 Monaten ohne Umwege zum Kometen. Pünktlich zum amerikanischen Unabhängigkeitstag wird er dort ein kosmisches Feuerwerk entfachen. Temple 1 ist der erste Komet, der von Menschenhand für immer verändert werden soll. Auch wir auf der Erde können dabei zuschauen. Denn der verwundete Komet schleudert reichlich Material ins All. Das lässt ihn aufleuchten, 40 Mal heller als je zuvor.
Genau am 4th of July, am amerikanischen Unabhängigkeitstag, soll das also passieren. Und das ganze Experiment wird nach einem Hollywood-Action-Film benannt. Also von Public Relations verstehen Sie was bei der NASA, von wegen staubtrockene Wissenschaft.